Discovery, go and throttle up. Discovery, go and throttle up.
All right. It's very rare going to catch me streaming on a Sunday, but today warrants it because we potentially have the ESCAPADE mission on Blue Origin's New Glenn rocket launching here in just over an hour from now. What's going on, everybody? How you doing? Yeah. Message received.
Discovery, go and throttle up.
You got it, Mutter. And go. Studies show that cows produce more milk when the farmer talks to them. Apparently, it's a case of in one ear and out the other. Okay. All right. We're already there. Okay, cool. Sweet. So potentially we have New Glenn Flight 2, guys. The reason why I say potentially is because the weather isn't cooperating down on the Cape, from what I understand. It is very rainy. It's very windy. With that being said, Blue has basically been following the count. They've been following the count and giving us updates here. With a report for propellant loading being underway 3 hours ago. So, oh man, I will say that is a nice piece of rocket. Very nice. Dang, that is a sweet rocket, you might say. Round, yes. What is ESCAPADE? Okay, so the ESCAPADE mission is a mission for under NASA, what's NASA Simplex program, and I have to look up the acronym. Sorry, it's the Small Innovative Missions for Planetary Exploration program. The ESCAPADE is a two satellite. It's a twin satellite launch. There's ESCAPADE A and B, and ESCAPADE stands for the Escape and Plasma Acceleration and Dynamics Exposures. It's a dual spacecraft mission to study ion and sputtered escape from Mars. So they're basically going and peeping Mars atmosphere, what's left of it. Yeah. Let's see. The science goals of the mission are to understand the process controlling the structure of Mars's hybrid magnetosphere and how it guides ion flows. Understand how energy and momentum are transported from solar wind through Mars's magnetosphere, and understand the process controlling the flow of energy and matter into and out of the collisional atmosphere. Nice. I think I got my level set. I'm hearing EJ, Alex, and Sawyer all at once. Hey, Moto with the 46-month resub. The fins look like they're made out of wood. It's kind of cool, but they are. It is a proprietary thermal protection system called Comet from Blue. It's Comet. That's what it's called. Is the dress blue or black or white and gold? I saw white and gold. No good. That's an old meme at this point. But yeah, Blue is giving updates. It says that everything is going. We had an update about an hour ago from them. New Glenn is fueled for its second mission carrying NASA's ESCAPADE. And they're also carrying a technology demonstrator for Viasat in support of NASA Space Operations Communications Services Project. Cool. Laurel, I heard Laurel. Asia. Another old meme. All right. Oh, you guys linked the 45th Delta 45 space report. Nice. All right, what do we got? Thank you, Noctilox. I appreciate it, man. This is something I didn't have teed up. All right, what do we got? A low-pressure system will develop over the Midwest today and track to the Northeast. Yep, that's me. Dragging a cold front into the Floridian Peninsula on Sunday. As the front approaches the region from the northwest, there will be enough moisture and instability in place for showers and thunderstorms to form ahead of and along the front. A few strong to severe thunderstorms may develop Sunday afternoon with a small chance of a thunderstorm wind gust near 80 feet per second. Oh. What is that, like 20? Hold on. Quackulate for the metric. For the metrics, 80 divided by 2.2. Oh. No, that's not 2.2. It'd be feet to meters, so it'd be divided by 3.3. 24. Yeah. 24 meters a second. Not great. The main concerns are cumulus cloud rule, surface electric field rule, anvil cloud rule associated with these showers. So the probability of launching today is 35 to 45. With a 24-hour delay, it's 25%. Liftoff winds, cumulus cloud, basically thunderstorms. It's cold, rainy, thunderstormy. That's not good. Hey, Kelly, what's going on? Feeling any better? Take it day by day, bro. Day by day. Yeah, the odds aren't great, but I'm here. And I'm missing the Patriots game for this. Damn it. You know, you came between me and Handig. Go Bucks. Ew. You're not missing much. Oh yeah. Okay, she's tied up now. I'll keep the score up there. Thanks for streaming. Hope you're doing well. I'm getting better, dude. How likely do you think that it's going to be launched tomorrow? I don't think it's going to be launched till much later in the week, drummer. This cold front, the way that was described, this front ain't going anywhere. The odds of successfully navigating an asteroid field are approximately 3,720 to 1. Never tell me the odds. Did you see that Indiana catch yesterday? Nah, I haven't. The only time I was near my computer is playing Battlefield yesterday on stream to just pop in and tell everybody that I'm still alive. So this doesn't fall under the FAA daytime rocket launch ban. I think this was grandfathered in before that happened. I don't know enough about that to really commentate on what's going on yet, though. So I really have to figure out what that all means. Oh, weather guy, you got to say, oh yeah. See, this is no good. This is no good. That's, you see the front? So weather guy, if I'm looking at this right, our front is right. Actually, you know what? Voice me. Let's go. Voice me. You tell me what's going on, pal. Same channel that we use for Battlefield. If you have time. Mine look better. Where's yours? Oh, current radar. All right. Okay. Oh, yeah, that's caca. That's no good. Well, let's rock and roll then, dude. What's up, pal? How you doing?
I'd be doing better if I had my audio set correctly. One moment.
So you can't hear me right now? So if I call you a doo-doo face, you're not going to hear it?
Oh, no, I can hear you just fine. It's just the sound's going out of the speaker, so you'd be hearing yourself calling me a doo-doo face.
Doo-doo face, doo-doo face, doo-doo face, doo-doo face.
Yeah, nobody wants to hear that. All right, I think we're good here.
All right. So tell me, so we got anvil, cumulus, scattered, like that's basically that is a nice way of saying there's a thunderstorm over the Cape, right?
Yeah.
Like
Yeah. So let's take a look at this image that you've got up right now. The underlying data is radar imagery. It's being covered up by a form of lightning detection. That's actually lightning as seen from GOES 16. And so what we're looking at right now are trends. You'll notice that cell kind of over the Cape. The lightning activity is decreasing as it's moving out into the ocean. That's good. Mm-hmm. But we've got all these other storms over the peninsula, and there's still lightning activity with them heading directly towards the Cape. Not great. As far as a front goes, let's take a look here. See if I can take a look.
The front, I think, which one was it?
Discovery, go at throttle up.
Yeah, that's going to be driven by the front.
Yeah, the front's behind it, right? It's like this is out in front of the front, correct?
Northwest. Yeah, let me see if I can get a better depiction of that for you.
Okay. Hey, Enroy. This weather guy knows his stuff. Yeah, no, he's good. He's good, right? It's like it's right in his name.
I've got my moments. Yeah.
Yeah, so guys, basically what he's talking about is you see this thing here and then this thing here. This big boy that's over Tampa right now or getting to Tampa, that's going right to the Cape. Right around the time of launch. This storm's moving pretty quickly from what I can tell. So this blob of fun is heading right towards the Cape, like right around launch time. My guess, this is a huge guess on my part, is that Blue might be able to get it in this gap right here. They might be able to launch in the gap. We've seen SpaceX and other companies do that before. They launch in the gap between like two big storms. Send it right for us, Ned.
They could do that. Yep. Right now, what they're doing is what's known as nowcasting. They're looking at the immediate short term, and radar is going to be their primary tool as well as these lightning sensors and things. Whether or not they're going to be able to find a hole that's void of precip, lightning, even anvil clouds, I don't know.
Yeah.
They gave what a 40% probability of violation. That seems modest.
Yeah,
but it's not impossible. What's their launch window looking like right now?
We are about
45 out.
Yeah, we're about 45 out. So they're looking at
Discovery, go at
45
throttle up.
past the hour. So that's gonna. I'm telling you, man, that's gonna be. It's
That's
gonna
tough.
be. It's gonna be. They're shooting for this gap right here. They're gonna hope that you don't get one of the storms over LC36 right when this goes. That's the big one. So guys, 36 is right here. If you look at the skid strip at Cape Canaveral, it's directly to the east of it. It's right there. So they're right on the very edge of Cape Canaveral, like right where the tip is, right there. The furthest east launch site is LC46, but 36 is right next to 46. There is a 2-hour launch window. W in Weather Guy, you tell me, this big sucker that's going right over Clearwater right now, that tells me that that's going to be there during the launch window, and maybe they could get on the tail end of it over here.
Yeah, what we're looking at right now are details on a fine enough resolution that all we can do is see how it plays out. But we're too in real time for forecasting models or any of those tools to really help us out a ton. We just have to look at observations. They've got people on the ground. In fact, they've probably got people launching weather balloons on an hourly basis.
So Sea Kraken is asking why there's so much static around Melbourne and Palm Bay. That's the radar. The radar is getting interpolation at close range, correct?
Yeah, so that is a great question. We call those features ground clutter. What's happening is the radar beam, obviously it starts out on the ground, but the farther out you go from the radar site, you're actually looking higher up. It's angled up to some degree. The stuff really close to the radar site is low enough, and the beam itself is actually oftentimes refracted some. So it's aiming at the ground, kind of. You're getting trees, dust, grass, insects, birds, all sorts of stuff that's not hydrometeors. That's not precip, that's not rain. It's just stuff. And we can see things in that stuff. If you zoom into that storm that's kind of over the Cape, you'll notice there's a little bit of a denser line in that ground clutter, just south of the storms. And we call that a boundary. That's a gust front or an outflow boundary. And what's happening is that's a miniature cold front. And so you've got some forcing that's convergent at the surface, causing some of that air to rise. And as it's rising, it's bringing up dust, insects, debris, whatever, leaves, grass, bits of whatever, car parts. And we see that in the air as sensed by radar, and that reflects what the surface situation is. We've got a little miniature cold front. We've got air moving up from the south of that, and then the cold air that's denser coming out of that storm's coming back down to the ground, spreading out as it does, and so you're getting that convergence zone. And that can actually trigger new storm development. So this is a dynamic situation. These are the things that they're going to be looking at.
So it's not just this stuff that's over Central Florida as a watch item. This sucker right here. That's
all of it.
Yeah, that could be.
You're going to get that all the time, especially in Florida. That's the sea breeze.
Yep. Yeah.
And because of the way the weather is right now, we're not seeing that sea breeze move inland a whole lot. A lot of times that will be the triggering mechanism for thunderstorms. We're already kind of past that today.
Mm-hmm. Cool. All right. So long story short, we're not looking the best, but thanks, weather guy. I appreciate you popping in here on short notice.
Anytime, man.
Okay. Cool. All right. Blues cast should be up and running, so let's go. I'm gonna pop in over there. Weather guy, thank you for your time. I do appreciate it.
No worries. Just let me know.
Cool. Please have weather guy on the streams more often. This is great. All right. Sure.
36.
All right.
Now, what's interesting is right now we're in the green zone, but we are tracking weather for launch at this moment in time.
Right.
The first, by the way, are also both fueled. A lot happening.
How's booster recovery
clear,
weather?
All personnel are launch.
It looked clean down range, Ari, but I'm not
console
sure.
In Rocket Park, and our red team, Ariane.
Our red team, that is, to be very clear, that's the team that has the task of fixing any emergent issues that might arise on the rocket during the lead up to launch process. They're located a little closer to the pad itself. They're in Hangar S on the Cape Canaveral Space Force Station there.
But let's talk a little bit about Launch Complex 36 for a moment. It's a historic location, 9 miles right from where we are sitting, Ariane.
Absolutely. We've said this before, we at Blue Origin, we're standing on the shoulders of giants, the scientists and engineers that have come before us in the space industry. And that includes those that helped launch 140 Atlas II and III launches that took place from LC-36. That include the Mariner, Pioneer, and Surveyor missions. And those missions sent spacecraft to explore Jupiter, Saturn, Venus, Mercury, and the surface of the moon.
Now, given that incredible history, how awesome is it that our second New Glenn mission is an interplanetary mission to Mars?
I forgot about Blues casting. I forgot.
Satellites are headed all the way to Mars, and they're going to investigate how the planet's weather changes over time.
Yeah, it's just so incredible, and we are so grateful for NASA for entrusting us with their payload today. They have been just amazing partners all the way through.
Absolutely. Tabitha, we talk.
So let me talk about what they're talking about. So New Glenn's launch complex is on. They call it Launch Complex 36. Once upon a time, Launch Complex 36 was Space Launch Complex 36. It was a twin pad launch complex. Okay, it was used to launch Atlas Centaur and Atlas II and Atlas III down the road. There was Atlas IIAS, Atlas III. Atlas III was the first Atlas rocket to use a Russian RD-180. That was about 20 years ago. And it was a twin pad launch complex. Where New Glenn stands right now is closer to the former Space Launch Complex 36B. 36A is basically where this camera is. Now, they are right. These Complex 36, utilizing the Atlas Centaur, launched probes all over the place because the Centaur's mint. Centaur is amazing. And there is heritage here. Not like heritage, like New Glenn is not Atlas derived or anything, but Atlas Centaur with that Centaur upper stage was utilizing an expander cycle with RL-10s. And Blue's second stage is basically a much, much bigger, more powerful version of that. So that's what they mean when they say they're standing on the shoulders of giants. Because Slick 36 launched a lot of Surveyor missions, the precursor missions for the Apollo program to go to the moon. It also launched Mariner, Ranger. It launched a bunch of stuff right out of this launch complex, which is cool. Now, once again, the payload on New Glenn today is the ESCAPADE payload. It's a twin satellite payload that is going to Mars. So Blue is launching payloads to Mars. It's a payload for NASA. And these two twin ESCAPADE satellites, there's ESCAPADE A and B. First of all, they're manufactured by Rocket Lab, which is super cool. A lot of commercial, NASA leveraging that commercial market that's there. What the ESCAPADE missions are going to do is basically they're going to look at trace parts of Mars's ionosphere. These satellites are designed to basically look around from what's left of Mars's atmosphere and try to discern how, if at all, how Mars's magnetosphere works. There's a good render of it. Mars doesn't have an atmosphere that's like Earth. It's kind of similar. NASA believes that it was similar to Earth at one time, but it has been degraded by solar wind over time. And it's thought that Mars did have plate tectonics at one point, but for some reason, some event decided to take Mars's atmosphere and slap it off of the planet. Like that. So the ESCAPADE satellites are going to go out there and they're going to figure out why. They're going to figure out, what's left of it and try to figure out why Mars got stripped of its atmosphere. Because it's no secret, if you look at a map of Mars, that you could see that Mars had rivers and oceans and stuff at some point. But not so much anymore. In your opinion, you feel like the BE-3U is still weirdly weak for the launch vehicle. Lots of gravity losses when they get up to the mass they want to send to orbit. I mean, dude, they make 700 kilonewtons of thrust. They've uprated them. They're up over 700 kilonewtons a pop. 1.4 meganewtons from the second stage. That's one of the most powerful second stages around, period. It's still not as much as the Saturn V. Now, and if Seakraken, if that's what you're getting at, yeah, I think a 4B3U setup would probably be more beneficial to them. But you might be looking at some mass constraints with your second stage at that point. Do you have a VOD that talks about Rook being renominated? I haven't been around, Darth. We will rope that into the space news on Monday. Okay, but how much mass is it? The B3, B3 used very, very light motors. Lava, it would be somewhat analogous to like a, not a Vinci engine, but it's somewhere, it's above RL10, it's above Vinci, like in terms of thrust. And, yeah, it is pretty dang light for what it is, from what I can tell. I mean, you're only going to be able to go so light when you have a dual expander cycle. So, the B3Us have separated turbines for liquid hydrogen and liquid oxygen, and they're using dual expander instead of a gear-driven expander. So those engines are going to be a little bit more heavy, but are a little bit higher mass. They're going to have what's in rocket science is called the lower thrust to weight ratio. But what they lack in TWR, they make up for in burn time, because these B3Us are some of the most efficient second stage engines that we have flying today, period, full stop. Oh, hi, storm clouds. Yeah, there's those clouds there. Hey, Nick, 40-month resub. Not really that. I have a feeling that the third stage will soon be implemented and it's going to reduce the TWR, that second stage. Oh, yeah, maybe. Maybe. Welcome to EJ's cast. Yeah, Trey. I like these guys. I know Ariane Cornell. I've met her before. She's cool. She knows who we are over here. But yeah, they're nice people. It's just, yeah, I'd much rather commentate, you know. Yeah, those ESCAPADE satellites are. Hey, Pie Guy, what's going on? Greatest, what's up? How are you doing? Thanks for covering the launch. I totally agree. Blues casting, dude. I wish I could go in there and tell them. Like, I just give constructive criticism because the potential is there. Like, I like Eddie. Eddie's cool. Ariane is cool. But they seem to have a certain type of message that they want to convey. And yeah, I don't know. It just.
We
here,
certainly
just
are,
listen.
Eddie. Thank you so much. We look forward to checking back in with you again throughout the webcast.
I'm doing all
keep
right,
an eye
guys.
on that
Thank you.
cloud that's lingering over you. We might have to get Eddie an umbrella.
Yeah.
Out there.
Yeah, it's important to add that the ESCAPADE satellites were supposed to be a rideshare mission with the Psyche, mission on Falcon Heavy, but they weren't ready in time. So NASA put them on New Glenn. It's a good way to get New Glenn into the commercial launch services for NASA. These payloads are awfully small, so it's relatively low risk payload.
120 feet tall. Wow. So that.
Yeah, Tennyson. Yeah, they really give off a daytime television vibe, and I don't mean that as like I'm not trying to like denigrate them or bad. Like I know them. They're cool, but yeah, it feels like I'm watching like Maury Povich or something. Like I don't like. I mean, and I love the hardware. I love New Glenn. This thing's awesome. I'm really happy that this thing is going to try that. They're teed up for their second launch. I've been pretty critical of them. They need to get this launch cadence up if we're going to get back to the moon. But yeah.
So we could give you some perspective. Oh, there we are. There we are. I'm glad we got some video.
Just got here. Do we know if there's a stage 1 landing attempt? There absolutely is, Phi. Oh yeah, they're going to land it.
It's good that you have the you've got there
Hey,
for
Chief.
some perspective, but we're still a
I'm
bit
fine
far
since
away
last
from
night.
it. But that's all to say that it is so large, and that's on purpose, obviously, right? We want to be able to put very large payloads on top of the rocket. It has this ability to take a lot of mass and a lot of large things from a dimensional perspective up into space. So what you see here is New Glenn is a 2-stage rocket. For those of you that are not space nerds like us, basically a stage in a rocket is just a rocket. So when we say it's 2 stages, we've stacked one stage on top of the other. So stage 1, GS1, is the one on the bottom. It's fully reusable. We also call it the booster. The booster will lift off and push the second stage.
Okay. Here's the thing, guys. The one thing I try to do is I assume that people are here. I assume that people come to this stream and they know what a rocket stage is. There's nobody that's going to be watching this that doesn't understand what staging is.
Discovery,
And if
go
they
and throttle up.
if they don't understand what staging is, quick Google real fast will tell you what staging is. You have first stage and a second stage. They split up the vehicle into smaller pieces so it can be more efficient. Because the name of the game with spaceflight is mass. You can't have it high mass, and if you can get rid of engines and fuel tanks that you don't need, you can be way more efficient. Can you explain what a rocket is? Well, it goes up and then it comes back down. You know, I never try to I always try to teach at like the high school level. High school to college level is where I like to kind of keep it in line for how I explain things. You know, I never try to do a glossary of terms. What I try to do is explain what I'm talking about when I talk about it, but I never try to go over what staging is. I never do stuff like that. Please mute this. So, okay. I know Ariane Cornell. I know her. I've met her through Twitch, actually, believe it or not. Ariane knows what she's talking about. I know she knows what she's talking about. I've talked to her about rockets. She knows what she's talking about. The problem is that she's managing the cast as well. When you are hosting a cast, guys, and this happens to me, this happens to everybody that does a cast, like big high profile thing. Like if you look at my explanations on the NASA spaceflight streams when Gene and I are hosting, my explanations usually aren't as good. That happens when you host a big cast. So excuse that, but yeah, that you kind of get into a rhythm and you're focusing on managing the cast in the background and managing the pacing, and you got a producer talking to you, et cetera, et cetera. That's why their casts don't come off. That's why they come off the way that they do, because they're trying to make sure it's a super professional, like Emmy Award winning cast. And that's fine. That's okay. If that's how they want to do it, that's how they want to do it. You're explaining code switching. If you want to call it that, sure. I try to never, ever do that. What you see is what you see. That's me. This is just me. I'm just me. Hey, daytime Emmy. Yeah. You have to dumb it down for the general public. No, you don't, JW. No, you don't. I have 15 years experience in this. You don't. You don't have to. Look, man, people come to a rocket. Like, that's the thing. Rocket launches are very niche. They're a very niche thing. Not everybody likes this stuff. the people that do come to watch your cast, right, are the people that understand this stuff, the people that are into it, right? They understand what staging is. You don't need to explain what staging is. Oh, there's a shot of the B-3Us inside of the second stage. Or inside of the first stage, inner stage. That's the shot of the second stage engines. That's the top of New Glenn's fuel tank. Looking so youthful. I'm shocked the Bruins jersey is not behind you like the old times. Yeah, Sam, I know. I still have that jersey, dude. It's down in the house. It's in my closet. Where's your voice? Were you screaming at the Patriots because we're one field goal behind? No. I've been out and about all over the place, dude. Yeah, your boy's tired. These last 2 weeks were a challenge, so to speak. But I don't want to talk about that. We're here to talk about Rockets, man. Hey, Jim Boy, what's up, man? So yeah, I mean, like, once again, Blue, I understand what Blue's trying to do. They're trying to introduce Rockets to younger people. But the problem is if younger people are really like this is, when I was younger, even like 10, 11, 12, I didn't want somebody to explain this to me. I wanted to understand what the adults understood. And that's the thing about rocket science, guys. That's something that I always try to explain. Like, the kids that want to do this stuff, the kids that are into this stuff, you know, when you're 13, 14, 15 and you're into something, you want to know everything about it, right? So the people that are here, the kids that are here that can rationalize what staging is, right? Like a 5-year-old doesn't understand what staging is. They're 5. A 3-year-old is going to be like, you know, yeah, it goes up and fire comes out. That's cool, right? You know, the people that are going to understand what staging is they already know what it is. The people that are watching this, that's always been my modus operandi. That's why I never explain what staging is. I just say what the Rocket's doing, and it's kind of self-explanatory, you know. Nice, Steve. There you go. WB-57 is headed downrange. Let's go, baby. But anyway, we're about 26 minutes out here. Let's see what happens, guys. The rocket is fully fueled. She's ready to go. Payload's ready to go. Everybody's ready to go. It's just, see those clouds that look like anvils behind it? Those aren't great. You do not want to launch into that. There's shots of Jacqueline. Jacqueline is Blue Origin's landing platform vessel. That's what they're going to try to land on. And this is a monster ship. It's gigantic. It's very big. Here, I actually want to listen to this. Hold on.
And actually, that feather is a center point.
Look at it, dude. Look at the people walking around on this thing.
4
She's a
days
beast.
Before launch, we check all our equipment, and we ensure that everything is working, everything is fully functional. We transit for 300 to 400 miles, depending on how far the landing location is. And once we get there...
What's the difference between Super Heavy and New Glenn's first stage? New Glenn's first stage is just a little bit smaller and a little bit... it's a little bit smaller diameter and just a little bit shorter, but it's almost as big. It is a big New Glenn is a big rocket. It's almost as tall as a Saturn V, and almost as wide.
Generally in the area, and right up to like 45 minutes or an hour before that's our final position.
That's what we're hopefully going to see today.
When the booster lands, the ROV will come out. Once it's mated with the booster effectively, we'll start pumping high-pressure nitrogen into the booster, which will allow the detanking process to continue to make the booster inert and safe for us to operate around.
Why are space terms and nautical terms so closely related? Well, Gav, the reason why space terms and nautical terms share a correlation is because we navigate in space using nautical navigation. Yeah, that's right. Spacecraft velocity, if you want to be very technical, not meters a second, not feet per second. Knots would be the correct unit of measurement. That's right. Yeah, I know. The reason why is because some of the orbital mechanics around orbiting celestial bodies, like the argument of perigee, time of perigee passage, right angle of ascending node, those utilize the geocentric equatorial coordinate system. So that uses longitude and latitude. So technically knots would be the right unit of measurement for velocity for a spacecraft. Now, The other thing is that how we navigate around in space, we use the stars. Just because you're 270 miles that way or about 400 kilometers that way doesn't mean that the night sky is going to be any different. Every spacecraft that flies nowadays has a star tracker on it that's looking at the constellations. And you can navigate and you can figure out your referential position based off of how the sky looks, just like you can on a ship. Same exact idea, dude. That's why the terms are borrowed. Spacecraft and, seafaring vessels share a kinship for those reasons.
Wait, hold on. We have someone who's just come into the studio. I hope it's okay. Dr. Fox, Dr. Nikki Fox, yes. Hey, do you think you could...
I don't know, Sea Kraken, I have to look.
Just for a second. Hi, sorry. I hope it's not as
Yeah, you have no idea about this stuff. Yeah, oh, that's Nikki Fox. She's a higher up at NASA.
Hey, it is. So how are you feeling about today? What are you doing here?
Oh, well, I'm working on console, working with the team.
There's another new blend
super excited. It's just an amazing day. We've waited a long time for this. This is for us such a day of firsts. First NASA science mission on a new Glenn. First heliophysics mission going to Mars. First interplanetary spacecraft.
Shaw, the star tracker isn't going to get messed up because it's looking at a star, despite that star being way closer than every other star. It needs that to figure out where it is. A star tracker doesn't really work very well when it can't figure out where the closest star is. You know what I'm saying?
Science, we are eyes on Mars.
Oh, we're all eyes on ESCAPADE and Mars today, aren't we?
Amazing. Isn't this nice that I believe your background is in heliophysics? How do you feel about going to Mars?
I think
we're mixing it up in the solar system for you.
Well, I will tell you, for heliophysics, the moment you leave the Earth's atmosphere, you're traveling in my neighborhood.
That's fair.
Right?
So
heliophysics goes all the way from the center of the sun to the very outer edge of our solar system. So I actually was one of the, I got to select this mission, so could not be more excited to be here with my amazing heliophysics team getting ready to launch this mission.
And especially given the...
They don't do this very often.
The advanced space has made this extraordinary trajectory that two spacecraft are going to fly around L2, but also again in your neighborhood.
First time ever, and it actually unlocks a lot of possibilities for us thinking about Mars going forward, because now maybe we're not stuck with these Mars launch windows.
Exactly.
Right.
So it's such a fantastic day.
Cool.
And really briefly, can you explain that for our viewers? Because what we're doing is we're kind of doing it in the middle period where we normally wouldn't send something to Mars, but we're going to sit it and let it wait. So explain that.
We are. So we don't have to wait another basically 13 months for Mars to get exactly in the right place and then launch. We are launching the mission. It's going to basically hang out and then wait for Mars to come into the right location and then accelerate full speed ahead to Mars.
Also,
so
that's
it's
why
just
clocks
a really
are important,
great,
like for
yet
ships.
another mission of firsts. Yeah.
Well, Forlorn, with ships, okay, all right, you guys know GPS, right? Global Positioning System. The Global Positioning System was originally made by the U.S. Navy. It was called the NavStar program. The NavStar program was basically a way so the Navy could figure out where all of its ships at sea were all at once. GPS relies on timing. So clocks, yes, Forlorn, it relies on timing. GPS has to deal with what's called time dilation. Time dilation has to do with the difference in gravitational pull on the surface of Earth, versus where the geostation or the global positioning satellites are in a medium Earth orbit. They have a half-day orbital period, so it's a 12-hour orbital period. So they're outside the gravel. They're about 12,000 miles that way. They rely on timing, and you have to account the differential relativity here in gravitational pull to understand this. And that's why timing with GPS for ship navigation is so important. Now, that doesn't necessarily have to do with like clocks on ships, but it's important for stuff to stay on time for GPS tracking, and that's a very, very quintessential piece of nautical navigation. That doesn't necessarily have to do with spaceships, even though spacecraft nowadays do carry GPS transponders. They do. But spacecraft I find nowadays are carrying more. They have global positioning satellite. They have star trackers. They have relative navigation sensors. They have all kinds of stuff. The more ways to track, the better, right? Oh, they pushed. That was 20 minutes a second ago. They pushed further into windows. So, guys, today's launch window is about 2 hours long. So the top of the window starts in about 20 minutes, and the window goes for about 2 hours. Clocks on ships are really important for navigation before GPS. Exactly. Yeah. Mm-hmm.
So Mark 1 is our Pathfinder. It's
Stop
using a lot
swearing
of
in
the same
Dutch.
technologies. It's a hydrogen-oxygen lunar lander, and we are aiming it for the moon this spring, and it's going to prove out a lot of the technologies we need to get the crewed lander.
Tabitha, Ariane, I'm excited to return to the moon, this time to stay. What else can we answer here?
I love it. Eddie, I mean, you saw in the video, we had some B-roll playing back there. You can see with the cars for scale and the massive building. Can you talk a little bit about why it's so big? I mean, our lunar landers, you know, are not necessarily going to be that big. Why does the building need to be that big?
What are they launching today? New Glenn is moving the ESCAPADE satellites. ESCAPADE satellites are Martian ionospheric satellites. They're looking around. And they're going to eventually make their way out to Mars and kind of monitor its ionosphere, what's left of it, King, so we can figure out why Mars, which we thought had a magnetic pole and you know, it was more Earth-like, we can figure out why it is the way that it is. Why have Blue Origin and Rocket Lab been so reluctant about mentioning each other in
Discovery,
posts?
go at throttle up.
I don't know. Probably some corpo nonsense. Stop talking about stellar navigation. It's the weekend. I don't have to take that class till tomorrow. Okay. Sorry, man. So if I say Resi, if I say things like mean epic, will you get semi-major axis? Will you get like did you already play Reentry? I have not played Reentry on stream. Doomly, I have not. Sextant is more naval navigation, but that's one of the big things that the Gemini program, guys, you remember the Gemini program was the program that precursed Apollo. Buzz Aldrin, second guy to walk on the moon, was the guy that he basically figured out. I mean, Buzz Aldrin, they didn't put Buzz Aldrin next to Neil up there for no reason. Buzz, like a mathematical genius. Seriously, he figured out how spacecraft fly through space. Like, not how spacecraft fly through space. That's technically Konstantin Tsiolkovsky. But he put that math to work. And he used a naval sextant on a Gemini mission to rendezvous two spacecraft together. It's the first time it's ever been done. Anyway, and he used stellar navigation to do it. He was the first guy to get it done. And he figured, basically, he wrote the book on putting Konstantin Tsiolkovsky's math about orbital mechanics to work and actually doing it. That was a big deal. But Buzz Aldrin, they didn't pick him to be the second guy to walk on the moon because of his good looks, but they could have, you know. Aldrin pioneered the math that I use every day. Seriously, his contributions to mathematical computation and spacecraft navigation are like, it cannot be understated how much that guy thought up about that we still use today about how spacecraft move. It's a nautical navigation class, so for me, it's more like zenith, Greenwich hour angle, co-altitude, things like that. Oh, that sounds like fun, Resi. Sounds like a lot of math, but it sounds like fun. Why is there a tube on the transporter erector that connects to the fairing half? That's for HVAC. You're talking about that tube at the very top up here. That is to keep the payloads cool. You got to remember, those payloads are not designed to work down here. ESCAPADE is not designed, they're not designed to work down here. They're designed to work up in space. So you got to keep them conditioned. The fairing has to be in a clean room environment. So two things. That thing is your HVAC systems for keeping the temperature and humidity down inside of that fairing. I don't know if you know Florida, it gets pretty humid down there. And the fairing could basically turn into an oven if you're not careful. Second thing, that HVAC system is maintaining a positive pressure inside of the fairing. So because it's pumping air into the fairing, it's it's pressurizing it, not really like too high. Basically, it's causing a draft inside of the fairing, and the fairing vent lines, the fairing vent caps down here are basically pushing out air. That prevents like bugs, leaf, dust, critters, Florida nonsense from going inside of the fairing. You don't want a bird like flying in there, right? So if a bird like tried to fly in, it would, the positive pressure of the fairing would just blow it away, because you don't want a bird inside of that dang fairing. You don't want a squirrel or a chipmunk or a gator or something inside of there. Now that's never happened, but that this is the HVAC. That's payload climate control. Basically, it's being air conditioned up in there, keep the humidity down, and to keep the pressure inside, so they maintain a clean room environment. Dust can ruin a spaceship, because think about it. Like down here, dust just settles on the surface, like on whatever, and you have to dust it off. Up in space, dust, static electricity. Static electricity makes dust attract to everything, and it's not that big of a deal, right? But just because of Murphy's Law, it's going to find something and short it out. So that's why it's important to maintain positive pressure. Now, the cool thing is, New Glenn, is that the inner stage is also pressurized. It's pressurized and purged. They're pressurizing the inner stage with nitrogen. They put nitrogen gas inside of that thing to make sure that no static electricity or anything, or they have what's called a reactive gas inside of the fairing. Our atmosphere has a reactive gas in it. It's that thing that you're breathing now that you need to live. It's oxygen. Oxygen is very reactive. It oxidizes things. You don't want, like, in the time that the spaceship's out there, you don't want it to rust. You don't want a component in there rusting out, because it's Florida. It's Florida by the ocean. It will rust. Right? So they purge the things out with nitrogen. They also do that. They also do that to make sure that no what's called hazardous gases. So in this case, it would be natural gas that has that is being recirculated out of the tank. They make sure that they pump nitrogen in there and purge the interstage out to make sure that there's no hazardous gases inside of the interstage. You don't want to like fly this thing, right? And then have your interstage full of leaky natural gas, right? So when you stage and you go to fire the second stage engines, it ignites all that gas inside of the interstage and your interstage blows up. I'm not saying that that's happened before. It hasn't happened with Blue, because they know, right? But let's just say that I'm pretty sure they figured that out a little bit earlier in the space program.
Discovery, go at throttle up.
Yeah, I could definitely feel that the crowd has been growing too. Goodness, at L minus 43 minutes. I mean, Ariane, we're feeling it. We're here at the desk. We're isolated, but we feel just as pumped as they do.
Just as pumped. And what gets me, like, as a nerd,
Dave. What's up, man?
Even if you're not a space nerd, look at that image. That is
stunning.
So cool. Like,
well, yeah, what's happening to it right now?
So basically, this rocket is fully fueled. We've got the liquid oxygen, liquid hydrogen on the second stage. That's what you see there on the top. And then you'll see the fins there, and just below the fins there you go. That's the New Glenn first stage with liquefied natural gas and liquid oxygen in there, and it looks.
Okay, so New Glenn's first stage is using liquid oxygen and liquefied natural gas. So LNG, what is liquefied natural gas? It's mostly methane. But what differentiates something like Starship that's using pure liquid methane with something like New Glenn that's using liquefied natural gas, especially if LNG is mostly methane? Well, depending on what application here, LNG is a cocktail of methane, propane, and butane. Okay? That's why it's called LNG and not methane. What the heck is going on with their logo up there? Their logo is just glitching out hard, man. What the heck? See, there it goes again. Anyway, that's why it's using LNG, liquefied natural gas. But see, that's what I mean about, if you have a boil off line that goes to this purge flame, because that's what it has. You have a vent line up here that goes back into the transporter erector and out to a circulation candle, like what's behind the closed caption there. You do not want propane, butane or methane pooling inside of the interstage. It will find something to combine with and it will explode. That's why they purged out the interstage, and that's part of the reason why the fairing has the purging systems on it as well. Oh, there's a shot up the business end. That's 7 BE4 engines. Each BE4 produces about 2,400 kilonewtons of thrust. It's an oxygen-rich stage combustion cycle, utilizing LNG and LOX, which is pretty crazy. I would do the Hank Hill voice, guys. I don't think I got it in me. My voice is toast. Well, oxygen-rich silver. It's closed cycle by default. I mean, you could have an open cycle oxygen-rich stage combustion, but you're just throwing efficiency out the overboard, quite actually. What are the tiny vents on each nozzle? Those are bleed valves, tech. The bleed valves make sure that the engines are primed and they're at operating temperature. Rocket engines, despite being superbly freaking hot, I don't know if you guys noticed the huge fireball that comes out the bottom of those things. What the hell is that logo doing up there? The huge fireball that comes out of the bottom of these things, a little warm. But believe it or not, the fuel pumps are moving extremely cold propellants, right? Liquefied natural gas, in order to exist as a liquid, needs to be really cold. Same with liquid oxygen. So it's an interesting balance of thermodynamics here, because your turbine machinery, right, your fuel pumps on the rocket engines need to stay really, really cold. But the engine is super freaking hot. It's a really big... now, a lot of rockets deal with this in a couple of different ways. With BE4s, what they do is they take the liquid oxygen and they move the liquid oxygen through the outside of the nozzle to exchange the heat and turn the oxygen into a gas. Then they take that gaseous oxygen and shoot it into a stream of liquefied natural gas, and that's what makes the BE4 do its thing. But those bleed valves need to be there to cool down the turbine machinery to make all that happen. So it's doing two things, right? You're getting the engines to operating temperature, right? And you're priming them. You don't ever want to dry fire a rocket engine. That would be like dry firing a rocket engine would be like operating a car engine, an internal combustion engine with no oil. It'll probably work for a second, and then it won't. It'll very quickly not work, because just like a car engine with oil, a little bit about cars here. Sorry, it's me. I'm going to make it about cars. I'm sorry. I don't know what you want. With an internal combustion engine, some of that oil takes the heat. It takes the heat out of the parts. Rocket fuels do that as well. I just told you the liquid oxygen takes the heat out of the rocket engine. If you tried to dry fire this thing and you got an improper mixture going into the engine, not only will it dry fire and not take the heat out of it, it'll probably explode because you'll probably get cavitation in the lines. Now, once again, I wouldn't wish any of this on Blue. I don't want anything to happen. They are bleeding their engines, so the engines will work, right, if we do see a launch today. 2-cycle oil, that stuff. No, article, that's really funny, using the fuel as a lubricant. That's what Raptor does. Yep. Hydrostatic bearings on Raptor turbo pumps. Believe it or not, the BE4 does the same thing. The BE4 does that. It does the same thing. The BE4 and Raptor are actually part of the same lineage of engines. They both are derived from the Air Force Research Laboratory's Integrated Powerhead Demo, or the IPD for short. The Integrated Powerhead Demo was a Air Force Research Laboratory study to do exactly as I said, to give a turbo pump hydrostatic bearing, basically where your entire turbine mechanism, so the fuel pump is submerged in rocket fuel and rocket oxidizer, depending on what motor it is. So the Powerhead demo does that, and it did that. It was the first one to test a hydrostatic bearing for a turbo pump. Now, what are the benefits of this? Well, the benefits are that any heat that happens in this, the fuel can just tank it, no problem. The big benefit of this is that if you have the thing submerged, provided you have your head pressure and your feed pressure into your LOX and liquid fuel impeller inlets are adequate, you can basically spin the turbine, the whole turbine and the whole turbo pump or power head or whatever it is. It depends on the rocket engine. You could spin it extremely fast. That's part of the reason why, I don't mean to talk about Raptor during a Blue Origin launch, but that's part of the reason why Raptor can maintain a 300 bar chamber pressure, because the liquid oxygen and liquid methane power heads are able to spin like it's, I don't know what the actual number is, guys. It's north of 60,000 RPM. And the BE4 utilizes something very similar. That's how they can get so much power out of such a small package. I'm still watching the radar. New storms over the Cape, but new storms over the Cape now, but I could see a window in the next 30 to 60 minutes. The day ain't over. Yeah, weather guy, they're going to target those gaps like I think what we were talking about. Did you see Elon's response to Jeff's post of Newglands? No, what happened here?
Discovery, go at throttle up.
New T0 is set for 3:18 p.m. Eastern Time. Morning glory. Oh my God. All right. All right, Javine. Yeah. Okay. Okay. I'm not showing that on stream, but all right. Thoughts on if we will see a magnetic bearing on a rocket engine anytime soon? You know, I don't know enough about magnetic bearings, turbine, to really say one way or the other. Hydrostatic is a really big deal. Hydrostatic bearings. Oh, look at that shot on the far right. That is a picture inside of the payload fairing with the payload attachment fitting in the 2 ESCAPADE satellites on either side. I wonder if the reason why Blue went for LNG is because Starship is going to use methylox, and at the early stage would eat up most of the methane in the region. No, that has nothing to do with it. You got to remember, Sea Kraken, liquefied natural gas is mostly methane. It varies. LNG can be it's a couple of different, formulations, right? But either way, I don't believe that liquefied natural gas goes below like 70 to 80% methane. It's that final 10 to 20% that's mixed with propane and butane, depending on the application. Is this the mission with a tiny payload and a giant fairing? Yes. Hey, Nazlik, I'm fine. Hibbit, what's going on? Hey, it's 21 to 10. All right, let's go. Let's go, dude. Okay. Still plenty of time left in that game. I'm pissed that I'm missing it, though. Blue just uses pure methane. They have said it themselves. Well, Resi, why do they keep calling it LNG then?
So you saw Viasat. We haven't. We should speak a little bit more about this payload because it's the primary payload, of course, is ESCAPADE. You actually saw there in the middle of the video. We had a little side.
The backup running back just ran a 55-yard Henderson. All right.
Inside the fairing. Live, ready for their launch to space today. But
okay, see these clouds over here? Those are anvil clouds. Not great. You see how it kind of looks? It looks kind of like an anvil. It's very flat on the bottom, and then it kind of goes up. It's flat on the top. See this stuff over here? No good. So cumulus cloud rule means that's just too many clouds, right? You don't want to launch through too many clouds. But then again, it depends on the type of clouds. The anvil cloud rule too, guys, anvil clouds are basically thunderstorms. Now, there's another one called the surface electric field rule. Part of your insulation is delaminating inside of the fairing. That is a really good indicator about the positive pressure systems that I was showing, that I was telling you guys about. See, there's a draft inside of the fairing on purpose. That's to keep these things cool and to keep critters and stuff out. Keep what's called FOD, foreign object debris, out of the rocket. But because that piece of, so these bricks right here, that is a acoustic insulator inside of the fairing. That's to make sure that the vibrations and the sounds don't wreck the sensitive equipment on the payloads. Part of their insulator is, their acoustic insulator is delaminating there. I'm not sure if that's supposed to do that or not. I'm pretty sure it's not, but I'm pretty sure it's not that big of a deal. You had Stevenson on your fantasy team. I'm sorry. Yeah, you should have gotten rid of him. Why use LNG instead of pure methane? Think of it kind of like octane with fuel. It really depends on the performance of the engine, Trey. That's really important. Blue makes it a thing to say it's liquefied natural gas. I don't think they're using pure methane. They make it a thing to say it's LNG. LNG is not pure methane. LNG is a mix of methane, propane, and butane, which is primarily methane. But now, Trey, why? Why would you put propane and butane in there? Thermal. That propane. If you mix propane and butane in with your liquid methane, you can use that propane and butane as a heat sink for your fuel. Depends on the application, though, right? Like if you're using a full flow stage combustion, right? You know, you could use propane with that. You could use butane in mixed with your methane. You know, but it really depends on the application. It's like octane of fuel. Like different octanes are used for different engines with different combustion or compression ratios. If you have a higher compression ratio in the engine, you need a fuel that's more resistant to detonation. Now, I'll be honest, I can't speak to the specifics of why you'd use propane, butane, methane, LNG versus straight methane. I'm not 100% sure. I'd have to go read. I know it's an application for the engine. It could be for cooling. It could be for lack of cavitation. That's also could be a thing. The propane and the butane could help keep the methane kind of contiguous. That it could help. I mean, I'm not a chemist, guys, so the way I worded that probably made some chemists go. You know? So it really depends on the application of the engine. And that's why they say LNG. They don't say liquid methane. Does Starship and Blue use similar fuels? Starship uses straight liquid methane. The straight liquid methane is easier to manage when you're doing a full flow stage combustion cycle. But with Blue's doing an oxygen-rich stage combustion cycle, you can afford to kind of tweak around with the propellants. Now, you know, it's kind of funny. You know, I could say you could tweak around with the propellants with the BE4. The reason why you could do that is the BE4 is not as complicated as a Raptor engine, right? Raptor's a full flow stage combustion. BE4 is, I got some flames coming off my head. The BE4 is a oxygen-rich stage combustion. Now, it's really funny to me that I'm sitting here saying that an oxygen-rich stage combustion cycle engine is not as complicated as a full flow stage combustion cycle. You got to remember, this is relative. Everything is relative. Anything to do with rockets is difficult. Anything is difficult. It's amazing that I'm sitting here making an analogy about a liquefied natural gas full flow stage, or not a full flow, oxygen rich stage combustion, saying that, oh yeah, that's not even the most complicated rocket engine we have. Because for the longest time it was. That was like top shelf tech, you know. But nowadays, you know, we got just full flow stage combustion cycle engines popping up all over the place. Well, duh, it's rocket science. Yeah. Hey, Twitchy Chippy, 8-month free sub. Thank you very much. Dead Scum had a 39-monther in there too. What's up, buddy? Don't let TF hear that. Sorry. I have a coworker that integrated the 7 engines on the first stage. Very small world. That's cool, Twitchy. I mean, dude, New Glenn's a monster. It is a monster of a rocket. It cannot be. I mean, I get it. You know, Starship is a bigger rocket, all right? Starship flies more than New Glenn right now. New Glenn will fly. They will scale up in the future. I wish they would scale quicker because we have the whole moon thing that we need to do. But it's important to abide with Blue. It's important for them to abide by their company's motto, Gradatim Ferociter, which means step by step ferociously. It means take it slow and deliberately. So it's going to take longer, but it's a much more rigid structure. You get stuff done, but you get it done on an incremental progress, which is fine. There's nothing wrong with that. The flip side of that coin is SpaceX, which is just like, oh yeah, send it. We're doing tests today, send it. All right. So you see a lot more launches, right? And Starship is a little bit bigger than this, but New Glenn cannot be understated for its usefulness. This is a useful piece of equipment. This is a gigantic freaking rocket. It's not as big as Starship, but it's almost as big as Starship. New Glenn has a 7-meter core diameter. There's a 7-meter fairing. That fairing is huge. Dude, you could take 4 school buses, 4 of them, and put them in 4 times symmetry inside of that fairing, and it would fit. 4 school buses. Think about that for a second. That is a huge payload capacity. That's big, man. It is a monster of a fairing. Falcon 9's fairings can fit inside of Blue's fairings easily. Probably 2 of them stacked on top of each other could fit inside. New Glenn's usefulness in a potential emerging commercial space economy cannot be understated.
Discovery,
it is a very,
go at
very
throttle
useful
up.
piece of equipment. Weird to think that if they do land this, it will only be the 2nd largest reusable first stage. Yeah, I know, right? Hey, outdoorsman, I'm all right. I'm getting there. My voice is shot. Yeah, been spending time in a hospital. I don't want to talk about it, homie. How's the count going? Well, we got to about 20 minutes of the opening of the window and they delayed it. They're targeting 3:18 p.m. Eastern Standard Time, which is about 25 minutes away. Excuse me. Ah, man, thank you so much for streaming. No problem, Twitchy. What's that?
Discovery, go at throttle up.
Oh, yeah. Jacqueline has Starlink antennas on it. That's pretty funny. Hopefully everything gets better. Yeah, about that. Hey, it's Florida. Wait 20 minutes and the weather will change. Okay. Opium has been administered. Thank you, Vasya. Appreciate it. Good stream. See you tomorrow. Okay. Is the flame trench full of water? Nah, I mean, it's pooling in there for sure, New Glenn, but there's drainage in the flame trench for this reason. That's why they have what's called retention ponds built around the pad. So you can take some, this thing is going to be a monsoon, whether or not, if the rocket goes off, right? They spray water on the pad to make sure that the sound from the rocket doesn't reverb off the pad and wreck the rocket on the way up. And it also is used to make sure that the pad doesn't get absolutely destroyed, because a lot of heat gets introduced like right in this area right here when the engines turn on. So they introduce a lot of water into the flame trench and over the pad, and the water has to go somewhere. I mean, most of it gets turned to steam from the rocket engines, but that still leaves a lot that just falls down into the trench. So they have drainage, and that drainage goes into retention ponds. If we see like a downward shot of the pad, I'll point them out to you. So there is water in the trench right now from the rain, from the actual rain. But don't worry, it'll drain. It'll go into the retention ponds on purpose. That's by design. Can the rain freeze and make big ice sheets? Condensation already forms, LoJack, from the cold propellants on the booster. That's all that is. That's what that ice actually is. So when they put cold propellants into the booster, right? It's like if you take a cold snack out of the fridge in the middle of summer. It'll start condensing. What it's doing is that cold is actually causing the ambient water vapor in the atmosphere to actually condense, right? Because it's so cold, the water actually gets close together. It's like, I'm cold, and it turns to a liquid. It goes through what's called a phase change, a localized phase change. So you say like, oh, will the rain actually create ice? Well, yeah, that's what that is. That the ice is formed on the outside of the booster because the propellants are condensing the water vapor in the atmosphere. And in Florida, it is humid. Not so much this time of year, but no humidity in Florida is like 60% humidity anywhere else in the world. Like, oh, it's a nice day. It's only 60% today. In the summertime, you get 100% humidity, dude. It's like you go outside, it's like going into a sauna outside. Now, because it's raining, guys, your humidity is going to be up, obviously. But yeah, weather's trending better. Okay, we'll see. Yeah. Yeah, if it wasn't raining, the humidity wouldn't be too bad. But that's the thing. It is raining. The storm should pass soon. Yep. I feel like they're a bit above 100% humidity right now. There's clearly water that the air can't hold. Yes. What I was telling about is like relatively this time of year, it gets less humid in Florida. Clearly, you guys are right. Clearly not right now. No, you're at 100% right now. Yeah, no, you're absolutely right. The retention pond that I was telling you guys about is on the other side of this tower. You can just kind of see it right there. You sure that's rain? I hope it's rain, Liz.
In all glory. And so I want to talk about how cool it was for us to go and see this engineering marvel.
Let's check it out.
Okay, so walk me through kind of the different components of this rocket.
Okay, so on the most very basic level, we've got GS1, and then stacked on top of it, GS2. It's basically like stacking a rocket on top of a rocket, right? So let's maybe start with the GS1 because it's doing a lot of the work today, right? And we want to land this booster as well. At the top, we call the forward section, you'll see kind of a gold section up there at the top where the 4 fins are. Right. Those fins, they move back and forth, right? So they help with directional capability on the rocket. The whole main section of it, though, in the middle is basically a big fuel tank. And then you get to the aft, the bottom section there, that has the landing gear you see in each of the doors, but it also has the 7 BE4 engines that are in the base.
Right.
At the top then, so that's basically GS1. At the top, basically from the white portion above the gold and beyond, tucked in there are the 2 BE3U engines. The part with the feather, again, that's all basically tank, liquid oxygen, liquid hydrogen for the propellants. I forgot to mention liquid oxygen and liquefied natural gas, the propellants for the first stage, so they're different propellants. And then kind of that nice, smooth top, that is the fairing. There are 2 halves of the fairing, and those will deploy off. Those will fall apart once.
You got to hold, guys. You have a tweet from Tori Bruno about how they use pure methane. That's very interesting, Redsi, because, they call it liquefied natural gas. Calling something LNG implies that it's not pure methane. Now, keep in mind, we could be dancing around each other here. They could be using 98% methane and 1% butane and 1% propane, and that would still be called LNG. The mixture, it really depends. Nobody's going to tell you what their mixture is. It's interesting that Tori Bruno would just say methane, even though Blue is very, very adamant about saying they use liquefied natural gas, which tells me they have a little teeny weeny bit of propane and butane in there, enough to basically say it's methane, but they still call it LNG. Interestingly enough. Hey, Ensign, 100 months. What's up, dude? So we're in a hold here. This is an unplanned hold. The weather's really not cooperating down there. It is raining cats and dogs. But SpaceX uses 100% methane, correct?
And it lands on the Jacqueline platform just in the last couple minutes or less even. We have 3 of the 7 engines that relight, and then finally just the final engine that lights. You don't need all of the power, all the engines, because you're landing what is effectively an empty fuel tank.
And something the size of a skyscraper.
Something that's the size of a skyscraper. So you do need power, obviously, but not as much, obviously, as when it starts. And then it should come for a nice soft landing on the Jacqueline. And if we do that.
Watching the Pats has the launch chances, 45% probability of violation. I would say that's about the same. It's not looking great. But yeah, see, wait. I said wait a second. Now it's not raining anymore. Now it's sunny. That's Florida, man. But if you look at certain angles behind it, it looks like it's gonna monsoon. Is your voice okay? No, my voice is shot. Don't worry about it. I'll tell you later.
To learn, as you mentioned, it's essentially a rocket stacked on top of a rocket, right? And the pad.
The Blue Origin tweet is they're entering a hold to allow more time for the weather to clear. New T0 forthcoming. So the T0 was at 3:18 Eastern Standard Time, so that was 18 past the hour. It's currently 1 past the hour. They're looking to move it further into the window. Guys, they have a 2-hour launch window today. So we're a little bit under halfway through the window. We'll see. But there are storms that are coming from across Central Florida. So they're, like I said, at the very top of this stream, when I popped in, I had one of my moderators, weather guy, in here, who is a weather guy. You could tell because of his name. We kind of theorized that there's kind of a gap in between the next storm that's coming, and they're going to try to shoot the gap, which is a little bit of a ballsy move, but for a second launch. But I don't know if they want to roll the dice. I'm not going to say no. The Patriots are currently winning. It's 21-10. Tampa has the ball. The 1st and 10 on the New England 21. So Tampa's probably going to put one in here. We'll see.
Jinx anything, but man, I feel
nice haircut. You look 10 years younger. Thanks, Rob.
All over the place, yeah.
Appreciate it.
But you're right. I've been talking to employees, for months leading up to this moment, and employees do feel good. Engineers feel good.
Okay, they feel great. Yep. Weather guy, there is one larger cell with LTG with lightning northwest of them moving towards Titusville. It's likely that this will stay north of the Cape, but it'll be close enough for the lightning and anvil rules for a while longer. Yep. You can't see the pad, Baron. Yep. Yeah, it's pouring out there. Low taper fade. Can you imagine if EJ had a low taper fade?
New T clock as soon as we get.
How are you feeling about them
right
sticking?
Now,
how are you feeling about them sticking the landing? It's hard to say, dude. It's hard to say, and I ain't just saying this just like, no, they won't do it. No, they didn't even get close last time. I'll have an answer for you if this thing makes it through if this thing makes it through supersonic retro propulsion, then I'll have your answer. It has music in it. Can't play it. Oh, yeah. Thank you, Manfu. Did they ever say what happened to the first booster? They had to, because it was an FAA mishap report. The booster did not do something that they wanted it to do. It had a problem with engine bleed control systems, meaning that they probably went to fire the engine and they had cavitation in the pumps and it blew the engine up. Rainbow. I don't know, King. It's actually kind of impressive. How do you even fix that? I don't know. They learned something. My guess would be propellant settling, drummer. They didn't settle the propellants enough, which caused inadequate head pressure into the impellers. That would be my guess. Drummer, like we've gotten shots from other launch providers of inside the fuel tanks, how during a coast period, all the propellant just kind of trickles around. That, if you went to fire the engines and you didn't have an adequate deceleration in the vehicle, albeit from aerodynamic drag or from downward facing thrusters, you're not going to get you're not going to be able to settle the propellants at the bottom of the tanks. And if you don't settle the propellants at the bottom of the tanks, you don't get the what's called proper head pressure inside of the inlet pipes to the engines. And that can cause the engines to basically cough. Like if a rocket engine asphyxiates like that, you have big problems. It'll explode. The reason why is because gases going into a fluid impeller, the fluid impeller will compress the gases. It'll compress the gases to a point where they will heat up. And if you're compressing oxygen to a point, if it's gaseous oxygen or gaseous LNG, you compress it to a point, it's going to generate a lot of heat and it'll melt your impeller, amongst other things, or cause a fire inside of your fuel pump. If a fire happens inside of your fuel pump, that's it. That's game over. Your engine's written off. because the reason why is because the fluid impeller is such a precisely machined part. The tolerances in there have to be nil. They have to be next to nothing. Like that fluid impellers inside of rocket engines are so precisely machined that if they're even if something is just a little bit off, it'll most likely the part will fail completely and it'll blow up. In this case, inadequate cooling inside of your fluid impeller from cavitation of propellants will cause it to melt inside of its casing, and it'll happen in a split second, which means it'll blow up. It'll go right to your thighs, and then you'll blow up. The tolerances here, guys, are to the micron inside of a rocket engine. That's part of the reason why rocket science is so difficult. This stuff is like human hair looks like an 8-lane highway to some of the precise tolerances here. These parts are very, very precisely machined. They have to be. That's the only way you can move that much propellant into the rocket engine and keep the rocket engine going. I did not see that. No good. I've been out of the loop, man. I haven't been really at my computer since Wednesday, except for last night. It'll go right to your thighs, and then you like rocket engines, don't you, Twitchy? And now let's chime in and see what's going on with the Bluecast.
Right? Like, it's so important, the A component of STEAM. But as part of the Club for the Future program, one of the cool opportunities that we give is we allow students to send postcards to space and back via New Shepard. And we also provide online STEAM-based lesson plans that are free for students and teachers to use.
Ryo, they're waiting on the weather. The weather is not great right now. I know this shot looks okay, but right over the launch site, they got a couple of storms passing. There's another big one coming. There's another big one coming, over Central Florida right now. And there's kind of a gap in between the storm that's just passing now and the next one that's coming because Florida things. They're going to try to shoot the gap, from what I can tell.
Animate engineering and math.
Yeah, but I kind of like it all.
Yeah, and arts today and anytime we get the honor of having you with us.
Let's be very clear. I'm not the one that's going to be designing.
How long is this mission supposed to last? Well, indefinitely, until the satellites break.
For ESCAPADE today, so like props to you guys. But I love.
Hey, Zach again. What's up, man? Surprised this is happening. I was on the phone with your dad Wednesday, B3 supply chain director, and he was like, we could launch as early as Sunday, but I think it'll be in January.
And Jeff himself has said that it is this generation's job to build a road to space so that future generations can unleash their creativity. Check it out.
It's got music in it, guys. I can't play anything with music. YouTube will flag it pretty bad. Why did it hold? Weather. We just got slammed with snow. It's turning into freezing rain like it's November, not February. I was just talking to Brimo's parents, and they said they got snow in Michigan, and that's like on the way to you. That sucks, bro. It is, dude. That's why I like living next to the damn ocean. It is, it's like 50 Fahrenheit out, which is like, I don't know, like 15 C. Not bad. It's straight hoodie weather right now. You can confirm snowing right now in the D. That sucks, bro. That sucks, dudes. Can confirm Metro Detroit got snow and sleet. That sucks. The gales of November. We didn't get any snow, man. It's like 50 degrees here. I was out in, I didn't even wear a hoodie today. Like, are you in Michigan? It's snowing right now? That sucks, dude. I'm right in the Great Lakes, which usually helps moderate this some degree. Unless you're Buffalo, dude. It's supposed to be 18F tomorrow in Georgia. Send help. Well, how is it going to be warmer when you're me, dude? Back again. This is also Arsenal. I think I mentioned that, but I've been joining my friend in his pro CS casting, and I needed a different name. Oh, okay. Okay, Zach again. Yeah, I got you, man. 82 in Tampa, 7C. Your window is broken open. Help. That sucks. Good luck with that, man. Get a hoodie on. Do you know where Kingston, Ontario is?
Discovery, go at throttle up.
Isn't that by Buffalo? That's close to Buffalo, is it not? That's somewhere in the lower part. Like you're not, that's not near, it's not Windsor. Like you're not near Windsor. That's in the southern parts of Ontario, right? If I'm remembering right. I don't know, man. I don't know your geometry. It's another country, or geography is another country. Go away. No, Niagara Falls and Buffalo. Kingston is on Lake Ontario, east of Toronto. So is Kingston, is it near Brampton, guys? You're getting mid-30s on Monday. Yeah. Well, whatever. Midway between Ottawa and Ontario, in Toronto. Closer to Ottawa, well on the Great Lakes. Yeah, I got you. Didn't blow up yet. Dradis, you live just outside the thumb of Michigan, and we've had a little snow on the ground when I woke up today. It finally melted in the last couple of hours. All right, Dradis. Yeah, the thumb. I got you. The hold is due to weather right now, Gold Fever, yeah. That's not going to happen, King. I'll tell you with pretty high confidence. That ain't happening. Yeah, Graham, that's pretty cool. I like the American flag feather shirt. That was pretty sick. Guys, what's getting me with the Blue Origin stuff is that you can definitely tell there's like a director behind the cameraman saying, cheer now, go, cheer now, which is... I don't like that. Your head is on fire. I know. It's because I got a lot of good ideas. The high tomorrow in Tennessee is 32 degrees. And I have to walk over a mile and it help you. Get a go buy a Carhartt hoodie, man. Or just go buy a heavy hoodie, dude. You're gonna keep streaming after the launch tomorrow. Tomorrow? Tomorrow's Monday, is it not? Yeah, I should be around. Boss man, you're here. That's right. And there's never been, I'm going to stay quiet when it comes to U.S. enthusiasm. Well, Dino, that's the thing, man. We get hype, but like, I don't mind if people get hype when something happens, but the rocket's just sitting on the pad doing nothing, and they're like that.
Discovery, go at throttle up.
Well, oh yes, very well done, old boy. Yes, quite. Very good. Yeah, it's just, believe me, as an American, I'm just like SpaceX's cheers, like when they land and stuff. That's cool. I dig it because it's real. I don't like this because it's like, yes, get excited. Come on, get excited. Show how cool it is. Like it's like, bro, the rocket's sitting on the pad. It's doing nothing right now. What are you doing? Stop it. Stop doing that. I think you didn't watch F1. Yes, I haven't watched anything. I haven't been near my computer except yesterday and today. I'm so hyped for this hold. Yeah, Joe, that's what I'm getting at, dude. Like, it's just... Oh, my goodness. Why do they have two different Lightning Tower? One is a fixed service structure for a crew access arm in the future, Grim. Thanks, Big Gun. No F1 spoilers. Okay. Truly an inspirational hold. Yeah, exactly, Ari. They didn't have all this hype when Flight 7 popped and Flight 8 and Flight 9. In fact, you could tell that Kate and Dan after Flight 9 were just pissed. Or no, Flight 8. They were just crap, you know? So wait, if it gets struck, we're just going to see somebody get electrocuted. No, those aren't lightning towers, guys. It's a lightning arrestor system. there are lines that go. Okay, that lightning rod, the white rod's at the top of the towers. Okay, it's a lightning arrestor. It's not a lightning rod. It's not a lightning tower. What is a lightning arrestor? So that rod is your lightning rod. Okay, there's an insulator behind it, and then there's wires that go down to various spots on the pad. If lightning hits the lightning rod rim, it does not go down through the tower. It doesn't go down through either tower. It goes through the wires. That's why it's called a lightning arrestor and not a lightning tower or lightning rod. The lightning arrestor system distributes it down the wires, and the wires are connected to insulators on the ground. Well, they're connected to the ground, which is the biggest insulator of all, right? So it gets dampened. The electrical charge gets dampened out through the grounds. You could see some of the over there. You could see some of the lightning arrestor system. It's right here. See it? Yeah, you guys can't see that. The screen's too small. Every pad around Florida has a lightning arrestor system in some way, shape, or form, because you do not want lightning hitting the thing that's full of explosives. Explosive propellants. We do not want that. That would be bad. That's why it's called an arrestor. It's called a lightning arrestor system. It's not. It redirects the lightning to the sides of the pad away from the explosive stuff. We're going on 4th and 5. It looks like we got it. Do you think that blue will change their GSC so we'll get rid of the flares? No. Not initially. It also keeps your villagers from being turned into witches. Huh. 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 Yep. I speak villager. Yeah, NG, that sounds right. I just watched the video behind you. What is a Kármán line? Oh, Cornelius, the Kármán line is kind of the universally regarded boundary of space. It's about 62 miles that way, about 100 kilometers. That's kind of where everybody kind of has agreed that the Kármán line is where space kind of begins and where the atmosphere kind of ends. The reality of that situation is that the atmosphere really doesn't end. The atmosphere goes all the way out to the moon in trace amounts. Earth's atmosphere does go that far. Yeah. We've detected trace amounts of Earth. NASA's detected trace amounts of Earth's atmosphere on the moon. The thing about it is that it falls off on an exponential rate. So the Kármán line is basically the point where the exponential rate of atmospheric fall off due to altitude, due to being outside of the grav well, really kind of gets to the point where it's more vacuum and less atmosphere. Yeah, in the reality, it's just a spectrum. You know, like it's a spectrum with exponential fall off. So the atmospheric pressure drops exponentially the higher you go. Lighting is north of Titusville. Is Virgin Galactic still a thing? Yes. Hey, Badojo. I'm back from work. Just in time for the big candle. Yeah, we might not see it today, dudes. Let's see. Hey, Flavia. Come stai? And Badojo, too. Come stai? Amico, come stai? Why are they not giving a new time? They're really trying to figure out when the gap is going to be in the weather. Toilet fan? They're looking at the weather and they're trying to figure out when the weather's going to be, when they're going to get a shot of clear and try to shoot the gap between the storms. And they still have, what the hell is with that? Look, why is their logo doing that? Look up there on the right. Click, 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 click. So benissimo, e tu. Bene. I'm good, man. Everything is good. That logo must have not be doing good with the progressive scan that the cast is being broadcasted in. That's my guess. Your head was fuming. From the flare stack. Yeah, yeah. The Italians, we're hot-headed, man. I don't know what to tell you. You should know this. What's wrong with you? That's the hold button. Oh, yeah, we got to click the hold button, yeah. Did you see what happened in Boca earlier? Did the crane, the tower crane. Why is the tower crane doing a 360 no-scope? It's a spicy meatball, see? I'm going over here. It's a lot cooler. They stopped it after they informed the security. Like, are you going to do more flame trench now that Jack is moving on? Out of the 76 flame trenches, Zizep, I've done 70 of them. So, yeah. There's a huge tower on your head. Yeah, it's my hat. What, do you not like it? Guys, I think we should do more NSF stuff, but that's on me to find the balance between the stream and doing NSF stuff. But yeah. EJ Dimmadome of the Dimsdale Dimmadome. That's right. Glad you went live today. Not sure how much I'll be able to watch later this week. Hope everything's okay. Boat. There's a boat in the range. Oh boy. So that boat may have screwed them, fellas.
And we find them as a sign of good luck. So Eddie, you are out there, you are with employees, you're at the best spot to see the rocket launch. But let's talk about something serious for a second. Let's talk about how hard it is to land the booster. For those of you who don't know, you probably do know if you're watching this webcast, on our first attempt, we weren't able to land the booster, but we were able to get our payload into orbit. Today, our big objective, aside from getting our payload into orbit, which is ESCAPADE, is we want to land our booster. No, never tell me the odds, and I like the name of that booster, so I want to keep it. So, Eddie, how hard is that?
Well, so first off, thank you for your patience. The weather here is looking a little better. The boats, as Ariane said last time, definitely safety is our highest priority. And the tortoise, for me, a sign of good luck. I mean, I think it's just a trifecta of signs that we're ready to not just launch ESCAPADE to space successfully, but to land this booster. So we learned a lot. Nothing substitutes flight data. So the GS1 booster, after it separates from the GS2 upper stage, it does a 180-degree flip maneuver so that the aft section is facing backwards, or basically back down to Earth, but in the flight path. And so that 180-degree maneuver is conducted by our reaction control system. They're peroxide monothrusters. We call them the severe weather agility thrusters. And those worked perfectly last time. We did the maneuver. And then the BE-4 engine goes for reignition. So the 3 center engines reignite what we call the exo-atmospheric re-entry burn. And its entire purpose is to slow down the GS1 as it re-enters the atmosphere so that its superior aerodynamic performance, those long strakes, those forward fins, can guide the GS1 booster over the Jacqueline.
Yeah, Eddie, thank you for such a good explanation for our viewers at home, because it took a little bit for me to understand, too, exactly. I'm like, why is it so difficult? And it's like, Tabitha,
it's hard.
It's pretty difficult. And I'm like, yeah, it's like when you watch the Olympics and you watch someone run fast, you're like, oh, I can do that. It's like, no, you can't. It's actually quite difficult. So, thank you, Eddie, for that great explanation. Again, we are currently in a hold. You are watching NG2, our webcast here. We are at about L-20 minutes. We're going to toss it right back over to the rocket. New Glenn is on the pad. It is feeling cool. It is looking cool. And it is literally, Ariane, very cool right now.
Discovery, go at throttle up.
Can't play the music. I'm sorry. I'm sorry. All right. I know I'm not saying this to be a jerk. I know that when you're on a cast, when you're on a live cast like that, man, everything is going through your head except for like actually talking technical. I've made this mistake before. I've made it on NSF many times. Somebody asks you a question and they ask you to answer it, in which case they asked him about landing the booster and he described everything but landing the booster. Stuff like that happens. It happens all the time. I've done that with NSF. I've been asked a question on the flame trench and I did not answer it wrong. Or I did not answer it right. I answered it incorrectly. I assumed they were talking about something else. That happens when you're not paying attention. That happens when you're not paying attention. About that boat fouling in the range for Blue Origin, we just heard him say that to the Coast Guard, he's limping around on one engine. That boat doesn't say like Elon on the back, does it? Yeah, answering the wrong question is very easy to do, Poison. You're absolutely right. So, yeah, he did a pretty good job considering they put him on the spot like that. That's the other thing you don't do. When you're in a cast with a couple of other people, you do not put people on the spot like that. Don't do that. Except if it's Flame Trench or something, like the whole point is to be kind of just let the topic go. In an actual cast like that, you don't say, okay, and we're going to answer a question here about how New Glenn lands. Alex, how do you do that? You don't put somebody on the spot at the last second. You usually try to say their name to tee them up for the question. So I'd be like, Alex, if I was hosting an NSF cast, I'd be like, Alex, how does the New Glenn booster land? We get a lot of questions about how this thing lands. How does that happen? Right? And, it gives you a second to tee in the other person because the other hosts that aren't on the air might not be paying attention. They might be looking at the back channel. They might be talking to the producer. That might be this happens to me when I'm not paying attention because I'm talking to chat. Landing today. Yeah, that's the hope, George. We'll see. Correct, Grim. Yeah, that's co-hosting 101. You don't put people on the spot like that. Don't do that. Unless they're a subject matter expert. Like, so if I was doing a cast and I had an astronaut next to me, you could put them on the spot. That's what they've trained to do. Put them on a spot. What are they? They're an astronaut. They'll figure out an answer. Elon and Peter be fishing for some Glennies. Oh my goodness. So we're still in a hold. There's a boat in the range right now. And I'm pretty sure that boat is going to screw Blue Origin's launch window. That kind of sucks, man. I remember when this stuff used to happen with Falcon back in the day. It's a freaking boat in the range. It also helps not to tee up the question, but give some additional info with the question that is framed, like you're educating the viewer. But it also gives the responder more time to formulate an answer. You get it, Brando? That's it, dude. That's how I roll when I'm hosting a cast on NSF. I'll say the question, I'll give some background information, and then I'll send it off. If I'm hosting a Flame Trench, that is exactly what I do to a T. Because you don't want to put somebody on the spot like that. Because if you put somebody on the spot like that and they didn't actually get what you're saying, like because they're doing 1,000 other things, you're gonna get the the rocket comes down and so it lands and you don't want that during a cast. You don't want that. You don't want somebody doing that. Space Force boat is going to the boat right now. Yep. Can they launch in the window that goes into effect tomorrow, or do they need a specific time of day? They would file a flight plan just like an aircraft, John. That's how commercial launches work nowadays. Sink the boat. I don't think we should do that, Ando. Like, I'm just putting it out there. I don't think we should do that, man. Yeah, Graham, that. Yep, yeah. Space Force has boats? Maybe. Yeah, exactly. Size up. That's exactly it. Oh man, this Pats game looks like a good game.
Investigator of ESCAPADE do?
So the principal investigator is entrusted by NASA to execute the entire project. So it's kind of like the buck stops with me. I have a team of excellent people around me, but I'm responsible for the production of the data, the definition of the science requirements, the execution, the technical aspect of the mission. I think it's a great model for how NASA sort of entrusts the completion, the execution of a mission to a partner like UC Berkeley, where I'm based.
And ESCAPADE is a really special project. We are so excited to be taking it up today on NG2. Tell me a little bit about what ESCAPADE does.
So ESCAPADE is a twin spacecraft mission going to Mars, orbiting Mars to sample the ways in which Mars and its upper atmosphere respond to changes in space weather. By space weather, I mean the million-mile-per-hour stream of charged particles that the sun is at all times throwing out. Sometimes that stream gets gusty, and the gustiness, essentially, of it is what we call space weather. And there's all sorts of ways that can happen. The magnetic field can get stronger, the speed can get higher, the density can get higher, and all those things have an effect on the Martian atmosphere. And over time, it can strip away the particles in the upper atmosphere. And we know that this has been an important process by which Mars's climate has changed over Martian history. Early in Mars history, up to about 2 billion years ago, Mars was at least occasionally warm and wet. It had a thick atmosphere. It was habitable. We don't know whether life actually existed, but it was habitable there. But then in the last 2 billion years, it's lost most of its atmosphere. And we think that the stripping of the atmosphere by the solar wind is a big reason why that happened. And ESCAPADE is going to be sampling and investigating these processes with a stereo perspective, with 2 spacecraft. Yep. And that's really important, because up until now, with one single spacecraft, we've only been able to measure either the solar wind itself or the effect of the solar wind closer to the planet. We've either had the cause or the effect, but separately. With ESCAPADE, we can have 2 spacecraft simultaneously cause and effect at the same time. And so that's the breakthrough that ESCAPADE is going to provide us in understanding the processes by which the atmosphere is stripped away.
And once we understand that, I mean, how does that affect us here back on Earth or future Mars missions?
Right. So it's important for a couple of reasons. One, I think we're just curious as to how planets evolve in general. Right. Like over the billions of years, planets, they change their atmospheric composition. They're more volcanically active, and that can affect the atmosphere too. And so this is an important piece, isn't the only piece, of course, but it's an important piece of the puzzle of Mars climate evolution. And that's interesting just because we love to explore as humans. But it's also important because space weather can have a practical effect on robotic spacecraft that we send to Mars future, and also humans when they explore Mars. This is important for a couple of different reasons. One, a big space weather event, what's often called an interplanetary shock or a coronal mass ejection, when the sun belches out a couple billion tons of hot plasma, often at high speed, high density. As that shock expands through the solar system, it accelerates particles to really high energies, high enough energies that they can go right through a spacesuit and cause astronaut health problems.
Right.
Yep.
And so the radiation on the surface of Mars, when you get a big enough coronal mass ejection, you can get 100 days worth of radiation in one day. This happened last year. Wow. This happened last year, June 6th, really 2024. The usual background level of radiation was increased by a factor of 100 for that day when that happened. And so if you're an astronaut on the surface of Mars, you don't want to be out away from your radiation shelter when that happens. And so ESCAPADE's measurements are going to enable us to better forecast those radiation hazards. There's another reason too why ESCAPADE's important, because we're also going to be studying the ionosphere. So this is a layer of gas in the upper atmosphere that's ionized. And that's important because that layer, it distorts radio signals as they pass through it. And understanding the variability and the structure of that ionosphere will help us to correct for those distortions.
For communication.
Communication, but also for navigation, because there's going to want to be GPS on Mars eventually. And understanding how the ionosphere distorts the GPS signals will enable astronauts to know better where they are.
And the weather isn't
cooperating. All these things are taken into account on Earth. It's all behind the scenes. So your phone doesn't have to like show you how they're correcting for it, but that's all behind the scenes on Earth. We want to be able to do that same error correction on Mars, and ESCAPADE will help us understand the ionosphere.
That's
It's really
super
cool to know that we're
actually.
thinking about these future problems now.
Yeah.
And speaking of things that are happening in the future, I mean, ESCAPADE is not going to be making it actually to Mars. The spacecrafts aren't going to be there for at least 2027.
That's right indeed. Yeah.
So what happens once ESCAPADE deploys? Kind of tell me more about.
Why don't they send a fast boat out to the boats out there? They do, but it's not a. But they send a fast boat, but it has a spinning bit at the top and it flies. It's a helicopter.
And so actually the viewers will be interested to know that we may not hear from the spacecraft for up to 3 hours after launch. And that is by design.
Okay.
Because we have 2 antennas, one on either side of the spacecraft, and they only work one at a time. And we don't know which one necessarily is going to be pointed towards Earth initially. So if the one that turns on first happens to be pointed away from Earth, we got to wait 2 hours until it decides, oh, I'm not hearing from Earth, and it switches over to the other one. So no one should panic if we don't hear from it within that first hour. But
Discovery,
once we
go and
know
throttle
that
up.
we have signal, we're hearing from it, and we know the solar panels are deployed and they're facing the sun, so that's called power positive. So it's a safe and a stable mode. Then we can relax, and then we can start focusing on the longer term aspects of the mission. And you mentioned trajectory. So yes, we are taking quite an unusual path to Mars. We are going to spend about a year in a very large Earth orbit, fairly gravitationally bound to the Earth. We're calling this the loitering phase. It's in the shape of a kidney bean. It kind of goes like this.
Lagrangian point.
And next November 2026, we're going to come back to Earth after going more than 2 million miles away. We're going to come back to only 600 kilometers above the surface. We're going to use Earth's gravity and burn our engines at that point, taking advantage of Earth's gravity to slingshot ourselves toward Mars. Because early November next year is when the interplanetary window opens for a transit from Earth to Mars. So all Mars missions before us have had to wait until this narrow 3 or 4 week window every 25 months. We're launching halfway between these 2 windows. So we're just going to kind of hang out in near Earth space until it's time to go to Mars. And this has never been done before. And this is really, really
Why not
exciting
just wait till the window?
this actually opens up the possibility
Because the rocket missed the window.
in the future.
John.
If humans want to actually settle Mars, we're going to have to send hundreds, maybe even thousands of ships to Mars within that 2 or 3 or 4 week window. And there aren't enough launch pads on Earth to reliably do that just within that window. So we could launch them over the course of a whole year, maybe, and we could like sort of queue them up, so that they're kind of lined up so they can go when that window opens. And so this is hopefully going to pioneer a way to essentially enable interplanetary settlement in the distant future. Who knows?
And once the mission actually starts, how long is the mission going to be going on?
So, so I mentioned November 2026. That's when we start our interplanetary cruise. We spend 10 months in that cruise to Mars, doing little trajectory correction maneuvers all the time, little tiny engine burns to like just barely tweak our path, so that we can.
You're going to target the end of the window, Baron.
In early September 2027, and that's when we got to do another big engine burn to be captured by Mars's gravity, and that's when we will be in Mars orbit. Then we spend another 7-8 months ish adjusting the orbits.
Wow.
So first of all, lowering the orbits, then adjusting the orbits. And this is important because ESCAPADE is doing another thing that's never been done before, which is the first ever formation flying around another planet other than the Earth or
a lot of firsts on this
the
one.
Moon. It's kind of like pearls on a string. Both spacecraft have to get into the same orbit. And it takes a while to adjust both orbits to make that happen.
Range is clear,
and also
fellas.
in the middle of that, there's what we call solar conjunction, where the sun gets in the way between Earth and Mars, and we can't talk to it for a whole month. So we kind of just have to chill out, go into safe mode, and just wait. And so this is the reason why it's going to take us an additional 7 months after we get to Mars, before we can start the science mission in spring 2028. And then we have an 11-month science mission, and that's also in...
So this is going to take us all the way into 2029.
Yes, exactly, yeah. It's, I think, May 2029 is the nominal end of the science mission. And I mentioned the 2 spacecraft are going to be the pearls on a string. We do that for the first 6 months. And that's important because we want to know how the upper atmosphere of Mars is changing minute to minute. So in the past, with only single orbiter missions, we've had to wait 4 or 5 hours to see how things have changed. And by that point, the planet's turned a quarter rotation, things are different. We don't know how anything changes on short timescales at all on Mars. ESCAPADE is going to pass through the same part of the upper atmosphere twice in a quick succession. So 2 minutes to 30 minutes
1.2
apart to
already
see
on
how
this
it
one.
changes on those short time scales. Once we're done with that, then we raise
your
one orbit, we
expectations
lower
about
the
the
other orbit,
game?
and then the two
Hope they
orbits are
win.
different, and they start precessing. This is a word for the orbital planes moving with respect to each other.
Okay.
Yep.
And this allows the two spacecraft to get much further apart from each other to make those simultaneous cause and effect measurements that I mentioned earlier, to understand the real-time
That's cool.
response.
They're
of the
going to
upper
use precession to
atmosphere
separate
the
Escapade
space
A and
weather
B.
events.
And so, with all that, understanding how ESCAPADE works, knowing that this mission is going into 2029, how do you feel today?
I feel excited. I feel a little anxious, as everyone does on launch day, but I am super, super excited. I'm proud of everyone who worked on ESCAPADE, at Blue Origin, at Rocket Lab, at Berkeley, at Embry-Riddle, all of our partners. Advanced Space LLC, they were the ones who did most of the work to design this innovative path to Mars as well. And so I'm just so proud of the whole team. Probably thousands of people have worked on bits of it up to this point. And we're so excited to reach this day, the culmination of so much effort and the beginning of the next chapter.
And the last question I have for you is there anything else you want to add as airman that I didn't ask about that you think is important to this interview?
So ESCAPADE is a very low-cost mission. ESCAPADE is only about 1/10 of the typical cost of a NASA planetary mission. This is a radical experiment by NASA in seeing whether they can accept slightly higher risk and less oversight in exchange for a much lower cost. And the idea being that overall you get way more science per dollar if you do this. And so
T-minus 29 minutes, 45 seconds. All right.
And it's because we are embracing, as I said, a lighter sort of
clock's running, guys.
By NASA.
They're going to try to send it. We'll see what happens.
There are fewer reviews. There are fewer sort of requirements. NASA's kind of letting us run a little more than they would typically. Okay. And NASA's oversight is often what drives a lot of cost. That's great, but it does come at a cost. And so this is hopefully a new way of doing at least a fraction of NASA's science portfolio with this higher risk, lower cost.
That's the way you do it. That's the way you do missions like this.
It's very exciting to have you here, to be able to interview you.
This is an exceptional sight. Just watching pieces of other rockets being put together.
NASA principal investigators for missions are always cool to talk to. These people are amazing. They live and breathe this stuff, dude. Look at how hyped this dude is. I'm into it. Let's go, man.
Rob, thank you so much. I appreciate your time.
Cheers. Bye-bye.
Cheers.
So obviously a great interview and a great opportunity to be able to talk to Dr. Rob Lillis there. If you were just joining us, you are watching the webcast for NG2. If you're looking at your screen, you might notice we have a new L time, which is L minus 28 minutes and about 30 seconds.
You launch the payload on the big rocket. That ain't working. That's the way you do it. Get your launches for nothing, then your landings for free. I'm just trying to match their levels of cringe. Sorry.
Of course, we're going to keep monitoring everything happening around NG2.
Yeah, I think a lot of people.
I'm going to speed us up. I'm going to resync. Yeah, okay. No, I'm not paying premium. Okay. Slim and none, P-Gamer. Cringe, mission accomplished. Perfect score. Okay, we're synced up. Oh, that ain't humidity. Well, it is humidity, but that's, yeah.
We've got this huge, what we call
Guys, I'm going to say we're more at a 60% probability of violation, but I don't know.
So be working and working properly and in right conditions.
When EJ's singing, we are truly in dire straits. We are the sultans. Bow, bow, down, down. We are the sultans of scrubs. Bow, now, bow. Boo, doo, 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 bow, bow, now, bow.
Out of line pressure, data, power that then could translate down the line.
Right.
Down
You're welcome.
pipes, literally, to the rocket. We have to check it out. So our team is on it.
Make it stop.
We have a little bit of time here to do so. But it looks like
hey, man.
The weather might.
I'm attempting to be cringe, okay? That's all I'm saying.
A constant rotation.
It's a flare stack, yep.
Say,
there's two of them.
It is great to see NG2 on the pad, ready to go.
That ain't the way you do it.
You know what they say, if it's going to happen, it's going to happen out there. And so right now, I'm going to toss it back over. Again, you are watching the webcast of NG2. We're at L minus 26 minutes before
You're doing great,
this
sweetie.
historic
Thanks,
launch.
Dad. Thanks, Dad. Yeah, that's not great. Oh, no, can't play the music. No, stop it. Stop it. Here's a shot on Jacqueline. That's their landing platform. There's a bird. Burb. What is that? Pelican. Come on, Pelican. Pelican. So the clock's at T-minus 25 minutes, 25 seconds here. Blue's going to try to send it at least once here. They have reported that there was a boat in the range, and then the weather wasn't cooperating, and now they seem to have a GSE problem, but we will see what happens here. Okay. Nice, Baron. 5 minutes until we hit the elusive 20-minute barrier for the third time. Oh, dear. Oh, dear. Hey, Marcel, whatever happens today, thanks for streaming and teaching us the viewers about rockets and stuff. 2 years, time flies. Hey, my pleasure. My pleasure, my friend. All right, I got to take a wicked yes. I'll be right back. Just enjoy the dead air for a second. I can't play the music. All right, what do you want? All right, I got to pee. Leave me alone. Stop yelling at me. Okay. All right, Eddie. Eddie, what's up? What's on your mind?
Engines are just eking out more and more and more thrust, better ISP for these engines that serves our customers. So like, for example, this year we delivered our 30th BE4 engine to our customer, United Launch Alliance. And in the building that was behind me when this webcast started, we have multiple shipsets worth of BE4 engines for New Glenn.
Eddie, do you feel like you have a particular love for one or the other, the BE4 or the BE3? I know you were out in West Texas for a long time. We do a testing of all of our engines really there, but do you have a favorite?
Yes, Redbeard, I do.
Well, no, it's impossible to have a favorite, right? They're all great engines. For example,
you can't say you love one of your babies more than the other, huh, Eddie?
No. Well, they're all great engines, right? BE3U, which runs on liquid oxygen, liquid hydrogen, is an open expander cycle, right? Those two molecules come together and they create a lot of energy and steam. And you know, BE3U originally started from the BE3 engine that now has flown 36 successful times on New Shepard, but they baselined it at 160,000 pounds of thrust. When it first flew earlier this year in January, it flew at 174,000 pounds of thrust. And this team is kicking butt. They keep increasing those thrust levels, keeping the performance high, and really it's all about the upper stage when it comes to the payload.
Ian, what the hell? What is happening? Did he just say that an expander cycle makes steam? Did he just say that? He just said an expander cycle makes steam.
Discovery, go at throttle up.
Don't have the atmosphere to push back in them and crumple them when the exhaust is being exhausted at supersonic, so faster than the speed of sound velocities.
I'm all right.
And that extra nozzle just gives you more momentum and higher.
No. You guys aren't listening. He said that the expander cycle makes steam. No. An expander cycle does not make steam. An expander cycle heats up hydrogen. Steam is what comes out of the rocket engine. That is not okay.
But it's the analogy that I like to think of.
That's a good way.
At least
Eddie,
they're blue balloons.
yeah.
They're going to be balloons, Eddie.
They don't have to be
Come on.
red. They've been big blue
Sorry,
balloons.
big-
He also, I remember, I went to
that's
one of his. He hosts these things here at Blue Origin where we can learn more about updates with different things happening with our engines. And he was explaining essentially the shower head method and how shower head is very similar to how an engine works. But Eddie, I think it's so great to be able to talk to him anytime about engines. And we're so grateful
nice.
for him. Of course, he's
All right,
out with our
that's fair.
employees. The best viewing spot to see NG2 take to the skies. You're looking at NG2 right now on the pad, and in this moment, we're going to toss it.
We're
back
inside of
over
20
the
minutes,
rocket.
19
Coming
minutes,
up here
45
shortly,
seconds.
We have a very exciting go, no go poll. So we're going to toss it over the rocket and kind of await that poll.
So, okay, the reason why I said that's is because the rocket engine technically does produce condensation. Anytime you're using a liquid hydrogen and liquid oxygen rocket engine, okay, generally the byproduct that comes out the back is steam. It's just water vapor. The reason why is because if you take two parts hydrogen, 2 parts oxygen, you combine them with each other, right, and you combust them, byproduct is H2O, water. That's how that happens. Okay. All right. I don't make the rules. Physics does. All right. No, that's the very plain Jane way of saying it. But with an expander cycle engine, in order to drive the pumps, so the B3U is a dual expander cycle. Okay. Meaning you have one pump on one side of the engine for hydrogen and another pump on the other side of the engine for oxygen. Now, these pumps have to have something to spin them. You have to spin the what's called a fluid impeller to pump fuel into the rocket engine and oxidize it. That's kind of important. Fuel pump needs to pump the fuel. Anyway, so what an expander cycle does is it exchanges heat with the outer lining of the nozzle on the rocket engine. They usually use hydrogen to do that, right? You could have dual channel, right? Which means you have the rocket motor around the outside of the rocket motor. You have pipes, right? They're okay. For the nerds, it's probably a milled copper channel and a liner. If I had to guess, probably wrong, but you have pipes. The plumbing goes through the outside, the physical outside of the rocket engine, and you could have hydrogen and oxygen moving through those channels, right? You probably switch it back and forth, and when the cold hydrogen and cold oxygen hits the outside of the nozzle, which is at ambient temperature, it starts to heat up. Now, expander cycle engines also utilize what's called a boost pump to kind of get the whole process going. New Glenn does have boost pumps. They are on the bottom of the second stage, just above the inner stage. It's kind of a pipe that looks like it's sticking out the side. Okay? You have a boost pump to start your expander cycle, start pumping those propellants through. When the hydrogen and oxygen hit the rocket engine, which is ambient temperature because it's in Florida, right? They start to expand. All right. And it's still, the rocket engine is still going to have some heat in it. It starts to expand because the liquid starts to heat up. It starts to pull the heat out of the rocket engine. And that gaseous expansion is what drives your pumps. It's what drives them through a turbine. There's 2 turbines, one for the oxygen pump and one for the hydrogen pump. That's what drives the turbines. And then the turbines pump fuel into the rocket engine. Now you can do, with that expanded gas, you can do a couple of things with it. You could take the gas and put it inside of the rocket engine and make a nicer explosion, or you could just dump it overboard. I do believe the B3Us, I think it dumps it, but I don't remember off the top of my head. But that's what I mean when I say it's not steam. You're not generating steam. That's not even an analogy. No, you're not. Water vapor is what comes out of the engine. The expander cycle doesn't generate steam. It does not do that.
Go.
OSM.
Go with the exception of weather.
RC.
Go.
ESR.
ESR go pending LVHT and PDI.
AC.
Go pending LVHT retraction.
Recovery.
Thanks, Fog.
Go.
GLI.
Go.
BMD.
Go.
GC, LC1, LC2. Perform final configurations for terminal count. Report when ready for terminal count gate checks.
LC2 copy.
Oh, this is RC and count 1.
GC copy.
Go ahead, RC.
A lot of potential sea surveillance violation with a cruise ship. We're still working on Coast Guard to make contact.
Oh,
As soon as
no.
I have it.
LD copies.
The cruise ship's leaving port. Oh, no.
So you just heard the go pulled there. It seems like a conditional go according to the weather. So we are going to continue to our terminal count, and we're going to continue to also keep an eye on the weather. So lots of things that we are tracking at this moment in time.
I think we should note there just a second. So first of all, our launch director, Megan Lewis, that lady is a boss.
Yes.
She is fantastic.
Okay, so they went through the go, no go poll. Sorry, I talked through some of it. Everybody seemed go. So the go, no go poll is when they go around at all the stations in mission control and make sure that every single critical subcomponent of the rocket is ready to go. One of the last people that they poll is what's called a range safety officer, or RSO for short. The RSO is basically the air traffic control for the rocket. The range guy is basically ATC. It's analogous to air traffic control for an airplane. Okay, if the range guy says don't go, you don't go. It's just like if you were on an airplane and pilots have the captain and the first officer have to radio the tower and get permission to get onto the runway and leave. If the range guy says no, you don't go. Now, just south of Launch Complex 36, about 5 to 10 miles south, so it's about 8 to 10 kilometers south, there's Port Canaveral. That's where Disney and Carnival launch cruise ships to the Caribbean out of. One of the cruise ships is scheduled to depart. The range guy came on the go, no go poll and gave a tentative go. Their go, with the exception of the ship. If the ship leaves port, they're not launching today.
We have a second stage that is one of the largest upper stages to ever fly to space.
New Glenn being a reusable launch vehicle is so beneficial to future lunar missions. It's going to allow us to keep that cadence going, where we'll be able
Sorry, guys, this has music in it. YouTube will nuke my entire VOD. Why is the ship more important than the rocket? I don't know. There are not Mars guys, notice to marine traffic. So the captain of that ship should know about the notice to marine traffic. You should know about it. Does the Coast Guard not have the power to stop the ship from leaving? If the captain of that ship violates the notice to marine traffic, then you got a big problem. The captain's got a big problem on his hands. Because the Federal Aviation Administration, the U.S. government, is the one that put that notice to marine traffic in place. So if you violate a federal NOTMAR, you got a big problem. Uncle Sam's going to be like, hey, it's me, your friend, Uncle Sam. Remember I said don't go there? And you did? Yeah, we got, hey, it's me, your friend, Uncle Sam. You remember me? Actually, you know who's gonna be the one knocking on your door? Sean Duffy. He's gonna be like, hey, it's me, the lumberjack. Hey, you remember when I said don't do that? Uncle Sam's a bit sleepy right now. Yeah. That's a good way to put that, random bozo. Not Sean Duffy. You know what? If he wants to go after people for violating NOTAMs and boats in the range, Fanta, he can do that to his heart's contention. Please do that. Actually, that would be you doing something that we actually appreciate for a change. I don't know, Zizep. We going? I don't know, man. We're inside of 11 minutes here. There's a cruise ship that's trying to leave Port Canaveral. And if it gets out into open water, it's a violation of the range. No, yeah. Jeff will be like, Captain, your prime delivery gets delayed, son. The captain will be like, no. All my Christmas shopping. Jeff will be like, deal with it. It'll happen just like that.
You recently had the chance to chat with our CEO, Dave Limp, about NG2 and what this mission means for science, but also for Blue Origin.
I certainly did. It was so great to be able to sit down and
Nothing,
actually
Flavia,
talk with
not
him.
yet.
And I think you guys are going to be surprised to learn just how much of this moment has really been building up over time, and how even when he was a child, Dave himself had an interest in space. Check it out.
Dave Limp.
This is a really big moment.
What's up, Dave Limp? Oh, buffering. Dave Limp.
Moment for Blue Origin. Can you tell me how NG2 compares to NG1?
Yeah, I think NG1 was obviously our first mission. There was lots to learn, and we did learn a lot, and unbelievably successful. And then we made our goal, which was to get to orbit. This time we're going to be a little bit more ambitious, and we want to not only get to orbit, but we have our first paying customer this time with ESCAPADE, and get them off to Mars. That's the first part of our goal, and then the second part of the goal is to land the booster out on Jacqueline. And if we don't, we have more over here in the factory that we're building, but we're going to give it our best shot.
Never Tell Me the Odds is pretty fitting for this booster. We are taking our second attempt at landing it for the first time. How are you going to feel if we land it?
Well, I certainly will not channel my inner C-3PO. I will be very ecstatic. I'll be on pins and needles up to that point, but it would be a huge achievement for the team and for Blue. I think that we have a good chance, but if we don't, like I said, we can build more, but I will be over the moon if it happens.
Now, New Glenn is obviously just one of the many systems we have here, right? We have New Shepard, we have Lunar, we have In-Space Systems. How are all of those organizations really working together to further our ultimate goals?
Yeah, I think each component of what we do has
After
a
this
piece
interview,
of trying
Rockets.
to get millions of people to work and live in space, and they all have their individual. But as it relates to this particular mission, a huge amount of people have put work into it. Obviously, our engines team in building both the engines for the booster, the BE-4s, and the BE-3Us for the upper stage. We also have a huge amount of work by the obviously New Glenn team building this vehicle, but also New Shepard has been a pathfinder. So all our avionics fly on New Shepard first, so that we can get a sense of what's going on there and get a sense what it's like to have flight-ready hardware. And so it takes a whole team, and it's a very big cross-functional effort across Blue.
We have more than 10,000 employees here that are very excited about this moment. I'm one of them. What is your message to those who are going to be watching our webcast and be watching NG2 take to the skies?
Well, I think everybody will be a little bit on pins and needles, I'm sure. But I would say that this is a culmination of a lot of work from a lot of teams. It's not the end point of our journey. Obviously, we have a lot more rockets to make and a lot more customers to make happy as we move forward. But to the extent we're successful here, I hope everybody at Team Blue takes a pause, smiles a bit, celebrates, because it'll be a great achievement for us. And we'll take that deep breath. We'll sort of embrace the moment and then move on, because we have a lot of customers waiting for us to succeed. And there's nothing that makes you happier in business and in your life when you see the smile on customers' faces.
Did you ever think that you would be doing something like this in your career when you're watching your rockets launch? No?
No, not in a million years. I was very happy making Fire TVs and Echoes, but it is a boyhood dream, and so to be able to have it, I kind of pinch myself every day and just amazed that I get to wake up and help this and lead this amazing team of people build incredible technology like New Glenn.
I mean, and in reference to that, one of the first things they ask you when you come onto Blue Origin is, what is your first memory of space? What is your first memory of space?
Yeah, I have a lot of pictures. It turned out my third, fourth, and fifth birthday, I have these old Polaroids of the cake, and they all have rockets on it. I was enamored with rockets as a kid, and never took the path where I thought I'd be running a rocket or a rocket company. But it turns out that it was very early in my life that I had a lot of love for it.
And we're so grateful to have you here at the helm. Dave, thank you so much for your time. I appreciate it.
Yeah.
And it was such a great interview.
All right, guys, I wanted to wait till after Dave Limp is done. So, guys, on the Twitch side of things, I have control about when I run the ads. I want to run the ads so nobody gets ads or pre-rolls or anything during the launch. So I'm going to run them now. I apologize. I hate ads. They're intrusive. They're annoying. If I have some control over them, it's to make sure that if you're not subscribed, I don't care if you are, it doesn't matter. You don't get an interruption during the launch. So I'm going to run them right now. I'll see you on the other side. At L-0, will the count turn to T0? No. Some people use L for launch. Some people use T for time. Is that a rooster? Why does... What is... Patriots pulled it out, Zyza. Big win. Big win.
Booster! ESCAPADE, and this is the team that's launching the rocket today. They helped build it.
Amazing. They are absolutely psyched. And what we're waiting for here is a go, no go, final go, no go. We're bringing this down to the minute on this one. We want to launch before our window, so we're waiting on the team to determine if that's great to go.
Oh, Eddie. Let's go blue. Let's go blue. Thank you so much. We are hyped. They are hyped. Since we are at essentially L-4 minutes, let's go ahead and toss it back over to the rocket right now.
Oh, no. Yeah, those clouds. You can't launch in those. See how dark they are? You don't want to launch into that. Now, here's the thing, guys. Why don't you want to launch into it? No, you can't launch in the clouds. Planes can take off into the clouds. Well, yeah, true that, dudes. True that. You ideally, with this rocket, since it's newer, you do not want to launch it when it's into the clouds. You're minimizing your chances of success there, or at least you're degrading your chances of success. Ideally, for a newer rocket, you want to make sure you have some ideal conditions to get some good flight data under ideal conditions, right? You don't, if Airbus or someone goes to test fly a new plane, right? You don't go and fly that into a thunderstorm on the first time, right? That's not a good idea, right? That you wouldn't want to do that. Those clouds are like way over there. They'll be way over here real quick. How much time is left in the launch window? About 35 minutes, guys, give or take. The boat went out even with the Coast Guard warning. That dude. Cruise ship. Okay. So in this particular case, guys, I think that cruise ship sailing out of port screwed them. This is a picture. I think, is this a Jerry Pike drone? Coming, yeah, this has got to be one of Jerry's drones. The freaking ship. See the rocket? The rocket's right there. How do you not see it? You moron! What are you doing? Oh my God. What are you doing? Stop it! Yeah, I'm just gonna go. Yeah, like, oh my God. That ship is heading south away, though, but you don't want to take the chance when it's that close, man, especially with a rocket like this. That's really close for rockets. NSF said it's a different ship. All right. Well, that's good. Banna. Is Jack's new job a cruise ship captain? I don't think so. That's probably someone who uses a shotgun in BF6. For real, though. For real. Or a suppressed LMG with a long barrel that they run and gun with. Lamest thing in the world, man. Yeah, I'm just going to tote this 240 Bravo around with a suppressor and an extended barrel into close quarters combat. Let's do that. I've been hurt, okay? I've been hurt by this. It was the fence, dude. That freaking fence, man.
Discovery, go at throttle up.
The captain. All right. Let's tone down the battlefield talk. Tone down the battlefield talk, dude. Jack got a new job. Yeah, he got a job at an aerospace startup, dude. His last flame trench was on Friday. That's called a skill issue. Shut up, man. You be quiet. Yes, he did. NSF is saying they scrubbed out. Blue took the clock off, guys. That's it. We ain't going today. I missed the Patriots game for that. Oh, well. I'm happy for Jack. Dude, me too. Twitchy, yeah. I'm pumped for my boy, dude. Jack is... Dude. I didn't get a chance to say this during Flame Trench. Jack is one of, like... He's one of the best friends you can have in this damn industry, dude. He's dude, like, how he acts on stream is just how he is. That's Jack, man. That's just... He's just a cool, fun, good friend to be around. Like... The type of like he's the type of person when you see him around, you're like, bro, Jack's here. All right, you know, like he's a good buddy of mine, and I really hope he does good. Really do. Wishing him all the best. Absolute G, and I'm glad to call him my friend. Me too, Ian. Me too. I'm happy we got to work together, man. Yeah, man. Yep. Eric Berger says scrub. Blue took the count off, guys. They're gonna run through the paces here. We're not getting any launch today. But yeah, anyway. I wish Jack all the best at the startup that he's going to work at. It will. I know where he's going to work. No, I'm not telling you. That is his prerogative to say, not mine. If that information ever comes out, you guys would be 10 times more hyped than you already are. It's super cool. Super cool stuff. Time for Battlefield? No. What kind of work is it? He got a job with an aerospace startup, Kirok. That's all I can say. And it's not like I have an NDA or something. That's not my place to say. It's up to him to say where he's working and what he's doing. Andril? Cool. Andril would be cool, but I don't think so. As an engineer? No. Spin launch. Is it Axiom? Axiom is out of Texas, Edmund. No. Palantir? No, I don't think so. Dude, I was on the Flame Trench. You know, I just called in real quick. They went through guessing. We went through guessing in the post show. You guys are guessing right now. No one has said it, dude. I haven't seen anyone say it. Like the actual thing. Not that I would tell you. Impulse? It's not Impulse. Nope. I haven't seen anyone say it. That's actually kind of crazy. Palantir startup? I don't think that Palantir is a startup, man. I don't think that Andril is a startup either. Oh dear. Nobody's got it. Nobody. No. One aerospace company. Ah, yeah. No, he's not working at the aerospace company. They aren't a startup either. Raytheon. I don't think. Lockheed Martin. Yes. Oh, yes. Yes, Ian, the startup of Lockheed Martin.
Patiently waiting. So I have an update for you. Today's NG2 launch is scrubbed due to weather, specifically the cumulus cloud rule. We're reviewing opportunities for our next launch attempt based on forecasted weather. I know we were all really excited to watch NG2 take to the skies today. We came down to the wire, and then there you have it. But my name is Tabitha Lipkin. This is Ariane Cornell. We're going to keep you guys posted and updated with all the information that we get as it becomes available to us. That will be on our social media.
Okay, we're scrubbing out for the day. Guys, it's Sunday. I'm going to head out. regular stream should resume tomorrow on my end. Well, we're not. If New Glenn is going to go tomorrow, then we're going to have another launch stream. But more cringe tomorrow. All right, yeah, let's go, man. Yeah, so I'm EJ. This was attempt number 1 for the New Glenn NG2 mission launching ESCAPADE, but unfortunately it did scrub. The weather is just not cooperating. Neither were the ships in the range. I don't think it's necessarily the cruise ship's fault, but it's funnier to blame the cruise ship, but it's not really the cruise ship's fault. The weather, guys, even if the cruise ship didn't sail, the weather wasn't going to cooperate. I looked at the weather forecast first thing on this stream. It ain't going to do it. You generally never want to launch a rocket, a newer rocket, in crappy conditions. Like, think about when Falcon 9 first started flying. They usually waited till it was sunny outside. Even when they did their first landings, they waited for ideal conditions. You don't, when you're testing a new system, when you're launching a rocket, there's a million parts on this thing. There's a million ways it can go wrong. Only one it can go right. Everybody says that, but that's the truth. You generally don't want to launch it into a thunderstorm. Generally, that's kind of frowned upon. But anyway, yeah, I'll give you guys updates here on the stream throughout the week as to when the next launch is. I don't think it's going to go tomorrow either. Tomorrow's weather is not looking great as well. So whenever it goes to launch, I'll be here streaming it for you. So thank you very much for watching. Once again, regular stream should resume this week. I think I'm out of the woods. Hopefully, we'll see. Anyway, yeah, I'm gonna head out. Let's go raid Shen. Oh, yeah, I was not prepared to do that. Anyway, yeah, I suppose we should pay this forward, shouldn't we, Weather Guy? We got a lot of people in here. Yeah, Shenru's playing EU5. Let's go see what he's up to. All right, on the YouTube side of things, I'll see you guys later. Go raid Shen for me, guys. Shen's a good dude, old school streamer, just plays games on Twitch. That's, that's the thing, playing games. Anyway, thank you very much for watching. I hope you guys have a good rest of your weekend, and I'll see you soon.